How about now? Folks online, can you,
Oh, good.
yeah, somehow my computer got muted.
Okay,
Ah,
there we go. So we're using this machine to capture everybody in the, I'm too close to it, capture everybody in the room and also the people online. So people in the room, if you speak, the computer, the Bobo, the owl will look at you. Okay, and we got as far,
I'm Pam Freeman. I am from Kenmore East High School outside of Buffalo, New York. He's my guy. I love him. And I actually am a teacher's aide in a life skills classroom. So I'm here to bring back some fun knowledge for our kiddos.
okay.
I am Lisa Keene. I taught many years in the Boulder Valley School District as a middle school science teacher. I retired from the classroom and now I work part-time with the University of Colorado on an outreach program where we take STEM lessons out into rural Colorado and other areas around the country.
My name is Kit McManus. I teach undergraduates GIS and spatial analysis schools at Columbia University. I do research full-time and I'm currently leading a project where we're developing online curriculum.
My name is Andrew Dundas. I work as a creative engagement specialist at the North Carolina Arboretum. That means I work in exhibits and I also coordinate our annual Mountain Science Expo, which is our annual STEM event related to the North Carolina Science Festival. And pass it over to my coworker.
Hi, I'm Charlie Zimmerman. I also work at the North Carolina Arboretum. I'm our coordinator for the Eco Explore program. Some of you might be familiar. We are a North Carolina-based community science project for kids. We cover lots of different disciplines of biology and earth science. We've had some really fun collaborations with educators, and we have a lot of wonderful partnerships with other professional educators in North Carolina. Yeah, that's about it.
Hi, excuse me. I had a harrowing driving experience here, North Carolina roads. I'd take New Jersey any day. But anyway, my name is Vicki Gorman. I'm from New Jersey. I teach middle school, 7th and 8th grade. And I do believe you have to be a certain type to accept the craziness of those two. So that says something for my mental status. I teach weather and climate systems, Earth's dynamic systems, and properties of matter. But what I normally do is take all three of them and put them into a more holistic approach to teaching. And I just want to give a shout out to the great organization that allowed me to come back this year and present my Funding Friday project. Last year was my first conference here. Sorry.
Hello, I'm Abel. I'm here as the ESIP support staff. So I'm working as a community fellow as a student. I just finished my master's degree in Earth System Science. And now I'm working as an intern geologist with the US Navy.
I'm Teresa Schwerin from the Institute for Global Environmental Strategies, and I am presenting today.
Okay, great. And
But Patrice, we'd like to get the online.
yes, and so I was going to the online folks. So let's just go alphabetical order. Angie, if you're available, could you introduce yourself real quick?
Sure, I'm Angie Rizzi. I work at NASA Langley Research Center in Hampton, Virginia. I'm the task lead for the My NASA Data website. I do have over a dozen years of teaching experience, science and math, and I will be presenting in a little while.
Okay, and Patrice?
Okay, I'm Patrice German. I live in Flat Rock, North Carolina, just south of Asheville. And I am a volunteer teacher's aide at Bullington Gardens for our Exceptional Kids program, getting involved in the symbolic monarch migration every year. And I'm also the Eco Explore contact at Bullington Gardens, which is one of 10 hotspots in Henderson County. So glad to be here.
Great, fantastic. Well, thank you all for coming and migrating here through the rain. It's not so bad right now. I'm going to do like one quick Mentimeter, just to kind of get a sense, so we have a sense of each other, of where we are in this world of data and interfaces. So I'm going to share my screen, and then, okay, so everyone has seen the agenda. So before we get to the Mentimeter, we have a wonderful cadre of presenters today, all of who either work with data or work with educators, and either collecting data on their own or through visualization tools. So first up, we'll have Teresa Schwerin, and then Angie Rizzi, and then Jessica McKay will be joining us from USGS. We'll have lunch over in the Expo Center. We'll walk with you, and we'll kind of cluster together because we leave before lunch ends, and it's an award ceremony. So, but we have a packed schedule, so we need to leave early. And then we have kind of what we're calling the unconference, and that's we can share projects that we're working on. A number of us brought some resources from our institutions, and we'll have a few other people. One person who wants to do a kind of present or getting some feedback on a NASA tool called Giovanni. And then we'll have some like short interactions here with a couple more presenters, and then Teresa and then Charlie will kind of get us going further with environmental data in the classroom, called an Echo Explorer. And then we'll wrap up. And just so you know, in case you didn't, as a reminder, we'll talk about implementation grants, the Funding Friday that happens tomorrow, but you make your posters tonight, and it's like a lot of fun, and it's not PowerPoint, it's like drawing your creative ideas for what you might want to implement using data. And then Becky will talk about travel stipends and an evaluation. So, just before we get started, I know Teresa's like standing there like, we're ready, she's ready. So we have Mentimeter, and if you have a connection to the internet, whatever device you have, up at the top is menti.com, and then here is the number, and I'm going to put it in the chat. I was going to put it in chat, but I don't remember how to do chat in the sharing mode.
You could just read it out.
I'll read it out. That's a good idea. So it's 1843 8630. There you got it. Oh, there.
I put it in the chat.
And April put it in the chat. Tech support, because that's why we have tech support. And here's a direct link. Cool. So we'll just, let you kind of put in your thoughts, or if you don't want to put it into Mentimeter, we can have you shout it out too. That's great. So far we have like metadata, spatial data, statistical data, and student gathered data. So we kind of have a nice variety here. Ooh, a few more. Satellite, numerical models, real-time, metadata again, wildlife observations, CDS files, more student gathered, we did that, air quality, satellites, it keeps moving, real-time data. As you can see, we have a number of different types of data that people are using within their teaching environment. So thank you. So that kind of gives us an idea of like how each other are using data in their life. And is there anything else I should mention? Let's see, restrooms are
That way.
that
So
way.
turn left as you come out and look for the very hidden wooden doors.
they're
They
beyond your
look
left.
decorative.
Do you have to go across?
No.
No, they're just right down the hall.
Down the hall.
Yeah. Exits here. If we have an earthquake, what do? Drop cover, hold on. Okay. I teach a lot on the West Coast. They're really important. Okay, so I'm going to hand this over to Teresa. And I'm going to put this in slideshow mode.
And yell at me when I've got 5 minutes.
Okay?
I'll wrap it up.
So, we put you down to 40 minutes, is it 45?
Sure.
Okay, and I'll hold up the thing.
All right. So my name is Teresa Schwerin, and I work on a NASA science education project called the NASA Earth Science Education Collaborative. And it's funded under a bigger NASA program called Science Activation. And the overall purpose of this program is to engage the public from kids to seniors, so literally from K to grade in NASA science. And actually here is Randy Neff from Southwestern Community College. Randy also works on another SciAc project, and Angie Rizzi, who's presenting after me, also works on another NASA SciAc project. I'm here in Asheville, so for you local folks, I hope you see me as a resource to help you. And I wanted to mention something for the folks from out of town on ESIP. If you're here this weekend, 2 places, North Carolina Arboretum, spectacular, and DuPont State Forest, also spectacular. So if you have time to do a little field trip, put those on your map. Okay. So the way that I engage the public in NASA science is through citizen science. And you may have heard this by lots of different names. Citizen science, community science, crowdsourcing, neighborhood science. The one thing they all have in common is people are all following the same steps. Gathering data, analyzing data, all in the same way, so that what one person does is comparable to another person. And so that's important for programs like mine, which is the GLOBE program. And you know what I forgot to say in the discussion of kept it a little bit short? I'm gonna have some trivia questions at the end. I've got some great books, so listen carefully, and you'll be able to pick whichever one you want. So keep that in mind. If I don't get to do it now, I'll do it in the afternoon. So Citizen Science Project I work on is the GLOBE program. This is an international science and education program, almost 30 years old. For most of that time, it was for K-12 teachers and students. 9 years ago, in 2016, we extended that program to out-of-school audiences through a mobile app called Globe Observer, so that anyone can participate in this program. So the tools, it's a mobile app, you can download, and it has 4, occasionally 5 projects. When there's a total solar eclipse, that tool opens up. But there are always 4 tools in the app, and you don't need special equipment to do these. You don't need training other than what's in the app. Everything you need to learn what you need to do is in the mobile app. And there are 4 things, and what they all have in common is they all help to complement or interpret NASA's satellite imagery. So they're providing that on-the-ground, up-close view to complement what NASA's satellites are seeing from space. And the things that projects you can do globe clouds, so you're reporting sky observations. What color is the sky? What type of clouds are in the sky? How high are they in the sky? And take photographs of the clouds and upload them to a database. Mosquito habitat mapper, I'm going to talk a lot about that this morning, but looking for potential places where mosquitoes, they breed. We've got a lot of places getting formed today with this rain, and sample for mosquito larvae. Land cover, which is literally what is on the land surface. Is it paved? Is it vegetation? Is it grass? Is it trees? Take photographs of the landscape. And if you want to go further, you can identify what type of land cover. And then trees, you can use the sensors in your phone to measure tree height. So you can get the app on either the Apple App Store or on Google Play. And once you download the app, you need to register for a free account. You just need your email to do that. So you open the app and you can register in the app, or you can go online and register through a web form. Occasionally people have a little bit of problem registering with the app. The version of the app might be a little bit different, but most people can do it within the app. But you do need to have access to your email to confirm your account. So if you're ever doing this project with people that you want to download the app and use it, make sure they have access to their email. And there are different types of accounts, and they can do different things. If you don't even want to set up a Globe account, you can still access the data that's being collected. There's about over 250 million observations in this database. Not just those 4 tools, but things like water quality, air quality, surface temperature, important to things like urban heat island. So you can access all of that data and download that data without even setting up an account. If you want to set up a citizen science account, a Globe Observer account, you just need your email. It lets you collect for those 4 projects. You can set up a Globe Educator account. You don't have to do training to do that, but that gives you benefits like you can set up student accounts, and writ large, any age student. So that if you're working with kids, maybe you're under 13, don't want them to download the app and register, you can set up student accounts for them to collect data. So those are all the different things you can do. I would suggest either registering for a citizen science account if you want to do it, or an educator account if you want to use this with learners. So question for you. Does it seem that mosquitoes are arriving earlier in the spring and leaving later in the fall than you remember? No? Yes, no? Well, the answer is it depends. In Asheville, we have about 22 more mosquito days where the temperature and humidity are hospitable to mosquitoes. It doesn't mean that there are mosquitoes on those days, just that those 2 things, those 2 conditions are right. There are other things that impact mosquitoes like vegetation and things like that, so not a simple story, but there are other places. This is Cleveland, has 27 more. This is all by a group called Climate Central. It does a lot of analysis of climate and climate communication. You can find the city nearest you in that. There are also places where it's decreased. And why do you think that's decreased in some places?
Right.
It's gotten hotter. It's too hot for mosquitoes. I don't know that that's a good news story, but there are lots of different reasons why. So you're right when you said, it just depends. And so one of the things important to NASA is that mosquitoes, they tell us about our changing climate. Is mosquito season starting earlier, ending later? Hitchhiking species of mosquitoes invading new regions. And one of the things I point out, the Aedes albopictus mosquito in the 70s and 80s hitchhiked on tires being brought in from Southeast Asia when that whole tire retread movement started. Tires are an amazing habitat for mosquitoes. And the range of mosquitoes, where we're finding them, is moving more northward. So can NASA see mosquitoes from space? No. No, they can't. But NASA satellites and NOAA satellites, they are observing conditions like precipitation, vegetation, temperature, that help to determine are there places where it's hospitable to mosquitoes and where mosquito-borne disease might break out. So it's useful data for climate modelers. And so with the mobile app, as a citizen scientist, you're making the connection between the satellite and the ground. And we ask people when they do a mosquito habitat mapper observation, I'll walk through what that means, to also do a land cover observation, because those complement each other. They give a little bit bigger picture of where those mosquitoes might be breeding. So a little bit of mosquito 101. Mosquitoes have 4 stages to their life. It starts when an adult mosquito, female mosquito, lays her eggs. Those eggs hatch into larvae. Have you ever seen the little, they're called wrigglers. They're really tiny. They can be from like 1/4 of an inch to 1/2 an inch. And I've got a tube with some samples of them that I'll pull out during the share-a-thon, so you can see what they look like. But you've probably seen like maybe your planter. That's where I usually find them, the planter under my plants, where there's some grade A stinky water. They like it. They then change into a pupa, and then the pupa turns into an adult. And the important thing is, mosquitoes spend 3 stages of their life in water. So that's why I was saying today is a prime day for those mosquito habitats to start forming. So with that in mind, take a look at this picture. Where would you expect you might find mosquito habitat?
Planters.
The canoe on top of the truck,
Mm-hmm.
the bottom of the slide.
Playground,
Mm-hmm.
Inside the kayak.
any place that collects water.
In the bottom of the truck too, if it's
Yeah.
open.
Yeah, there might be some hitchhiking mosquitoes on that camper going somewhere else.
The barbecue.
Mm-hmm. And then inside, what are some places, they're not just in habitats inside, but also outside.
I don't know, but these people have a lot of leaky things. There's a lot of leakiness going on.
A lot of weeds,
The tires, oh.
tires,
Massive.
under the sink, trash. You know, something as small as a bottle cap can hold enough water for mosquito habitat. So clearing trash, it's good as a steward of your environment, but it's also good for your community health. And then finally.
They're screwed.
I never feed my dog outside. I never have his water bowl outside.
The water bath, but there's the whole
Yeah.
marshland back there that
Water
you're.
bath, the grill, the little place under the grill where water might collect. And you know what? A secret place, trees, tree holes. I have a tree in my front yard that has a big tree hole where water collects, and I don't always think to look there. And there's a specific kind of mosquito that breeds in tree holes. Okay, safety first briefing. So while we're looking for mosquito larvae, they don't bite, they don't spread disease, but if you're outside and you find mosquito larvae, there's a good chance they're gonna be adult mosquitoes. So take precautions, take safe practices, long sleeve, insect repellent, clearing standing water, all of those are good things to practice. And these are pictures with the larvae magnified. I'll show you during the share-a-thon how little they are. These are magnified like 60 to 100 times in these pictures. And so this is what you do. Everything's in the app. It walks you through. You find a place, you look for places standing water is collected, are there larvae, and open the app. It automatically enters the geo-coordinates of where you are. And we ask people, there's an accuracy little button to click that until it's under 12 meters. So it clicks onto the GPS. And then to describe it. What is the source of water? We've got different categories, and you can walk through and think, is it still water, flowing water? Is it an artificial container, a natural container like a tree hole? We've got an activity that's building mosquito larva trap. Is it in a trap or an over trap? And then if you want to go further, you could stop after these first two, or you can sample and count how many are there. And if you want to go further and get a little clip-on microscope, and I've got some examples that I'll show you during the share-a-thon, you can walk through a key and identify whether they're one of the 3 main genera in the United States that can spread disease. And it asks you, has pictures, does it look more like this or this or this? And so you can identify what kind of mosquito it is. And then at the end, it asks you, did you eliminate standing water? If it's an artificial site, and really important to say, we're not looking for people to clear wetlands, we're looking at artificial containers. And so with mosquito-borne disease, we really only have 3 strategies: surveillance, looking for, mitigation, getting rid of these habitats, and education. And we do all 3 of those things. And we've got a bunch of different kinds of activities, videos, tutorials, games, and I've got lots of examples of these. One of the activities, it's called Mosquito Larva Hunters, and it's for middle school age kids. You can earn a badge and a certificate, so level 1 and level 2 larva hunters, where you can practice. It's got a bug shot lineup where you can identify whether something from the picture is a mosquito or an imposter, looking for clues. So the thing about citizen science, observing is a skill, and the more you do it, the better you get at it.
I have a question. So
Yes.
you obviously have a lot of opportunities for education here. Which ones get used the most? Like out of activities, about mosquitoes, videos, books, tutorials?
I'd say they're all used, and we've tested them in lots of different out-of-school settings. My favorite is the Zika-zine, and I've got one of those. It's a story of 3 80s mosquitoes, and I'm on Team Maurice, who dreams of being a first mosquito in space.
Oh,
And then Wanda informs him.
So
NASA's not
you
flying
like the book the
mosquitoes.
most?
And I have one of those for the trivia question.
Okay, all right.
We've got a bingo style game on,
Okay.
all of these are things that help you to either learn some of the background knowledge you need or practice the skills.
Oh,
doing
and it's
citizen
so you
science.
have a build a mosquito larvae trap, and the middle one, is that one of those things that goes?
Yes,
Okay.
I go to science conferences and have, people will jump across the aisle, they're so fun, cool.
Yeah.
So, we've got the mosquito tellers, and we've got like 6 different ones on biology of mosquitoes, mosquito prevention and protection, and we also have a blank teller, so you can make your own teller. And the bingo style game, it's to learn what are the different habitats, and play it as a bingo game. And I worked with the library in Texas that tested this out, and she called me and said, I am so sorry, but we can't play bingo in the library because it's considered gambling. I know you're not asking me to gamble. So we came up with some adaptations. So you can name that habitat so someone describes it, or like a Pictionary game where you draw that habitat. So that's one thing also. These activities, we designed them to be very adaptable for lots of different settings.
I just have just a comment to answer your question about what activities are great. When you guys first implemented Globe, we were on board with Dorian Yanni. Do you know Dorian?
Yes, Dorian Janney, very much so.
Anyway, we built the larva traps. We used a drone to go overhead to see if we could find mosquito areas. We never collected a single larva, never. Now, why? Because our area sprays for mosquitoes.
Yes.
So I would love to see something added to mosquito habitat to say, check with your local authorities, see if they spray, when do they spray, and then go ahead and do the experiment before spraying, and then maybe after spraying if that's possible. Because the kids were so disappointed.
Yeah.
They would go out every
Yeah.
day and they would check these things that were in, we made it, it was fun to make.
Yeah.
And it was a good engineering type
Mhm.
project for them. I teach middle school. But I would love to see Globe do that because this mainly started because of our Africa partners. And the fact of malaria and all that other stuff.
Mhm.
But we have, the Culex mosquito does West Nile. And so that's something to also consider, how many Culex you find as opposed to the Aedes, and see if that goes with your health department as to how many cases of West
Yeah.
Nile. But anyway, but if you wanna take that back to,
Yeah.
please put in something there about whether you
Okay.
spray.
And so, yeah, good point. And so there's lots of different investigations, like you were
Yeah.
mentioning.
And what is that thing called that you fold up? Is something catcher? No.
Cootie catcher.
Cootie catcher. Thank you.
Oh my gosh.
I'm gonna see if I can find a template of that.
From the past.
So quick example, we're working with the President's Malaria Initiative and the CDC, and community entomologists in Ethiopia are using mosquito habitat mapper to identify locations of dangerous malaria vectors. This one, I'm gonna go to the next one because we're working with, as I mentioned, CDC and the President's Malaria Initiative and the University of South Florida on this initiative to use automatic image recognition with the citizen science photos to identify, what kind of mosquito it is. And Rusty Lowe, who works with me and Carla, she's our scientist lead from Mosquito Habitat Mapper. And she was looking through the data and she found an Anopheles mosquito with the habitat identified as a tire. And that's unusual. She thought it was bad data at first. And then they went back and they talked to the person who collected the data, and it was found in an artificial container. And that's important because that particular malaria, one of the things you do are night nets, mosquito nets. These are day biters. They're biting during the day, so that's not useful. So it's helping to identify where the ranges are expanding so people can do something, work with their health department. And so that's a picture of in Madagascar, this one, the mosquito was in a tire and she was like, this can't be right. Followed up, yep, that's what it was, and that's what kind of mosquito it was. Some more pictures of people looking for habitats, different sources. How am I doing on time, guys?
You got 15 minutes?
How much?
Check. You're in 22, you're doing good. You've been going for 22 minutes.
Okay,
You're a little over
I'll
halfway.
slow down a little bit there.
Yeah, take your time.
Okay, so data, this is all about data. So I'm going to walk you through how do you access that data. You don't have to have a Globe account to do that. And so here's how you do that. So all Globe data is open access. There's some tools like an API, automatic programming interface where you can download the data in big batches, tutorials, a data user guide with all the metadata and defining all the metadata. You can search and download the data using the Globe Advanced Data Access tool and the data visualization system. This is just a place on the Observer site where we pulled data sets that have been used in publications, so you can find those there. If you go to globe.gov and you pick Visualize Data, oh, they got the QR code is right where that thing is. I'll remember that next time. But if you go to globe.gov, Globe Data, Visualize Data, that'll take you to an interface, and this is just part of the screen, where you start with the sphere. So Globe protocols fall into these 4 spheres: atmosphere, biosphere, hydrosphere, hetosphere being soil. And why is it hydrosphere, not biosphere? Well, larvae in water, mosquitoes in water. So pick Hydrosphere, mosquito habitat mapper, and you can select whether you want to, what you want to see of those observations. Hit submit.
You're tapped out of PowerPoint.
Stop working. I turn it off.
You can have one or the other.
It doesn't want me to go.
You can have the QR code or you
Oh,
can.
there it is. Okay. And then you can pick the date. Do you want just one date and time? Or do you want to look at data counts over a range of dates? And here I picked all the mosquito data collected July 15th, 2023, and there are dots on the map. You can see if you're looking for dates where there's data collected, it has a little symbol, meaning, yeah, there was data collected on that date. And you can use this animation tool to see it changing over a week at a time. Another way, we created a dashboard, which I like. Andrew Clark on my team, he created this for a data challenge we had where we were looking for people to collect as many mosquito habitat observations as land cover observations. And so what I like about this map is as you zoom in, you can pick the date range up at the top right that you're interested in. And then they've got different map layers. So this is the key for mosquito habitat mapper, the number of photos, the color dot signifies that, land cover, the total photo count. Trivia, this is not one of the questions, but you see a big spike there? That was on April 8th.
The solar eclipse.
What happened on April 8th this year? Total solar eclipse, and one of the things we had people do with the eclipse app is look at the clouds, look at air temperature, and also do a land cover observation as part of that. And so as you zoom in, and you can click on a dot, and you can see the photos and kind of page through them that way. And you can see the photos of the larva that we submitted. And this is one that was submitted in Madagascar. Angie Rizzi is going to talk next about the data cube in MyNASA data. Just want to point out one of the activities that they have is a globe mosquito habitat activity. So looking at climographs for 2 different cities and determining what are likely months you might expect mosquitoes to emerge. So I wanted to let you know about that. And now it's time for the trivia. Let me find my phone. Okay, so I've got some books up here. I've got the Zika-zine. I've got the Field Guide to Citizen Science. I have Elementary Globe is an amazing resource. It's got, this one is, do you know that clouds have names? That goes with the cloud, Globe Observer clouds. And in this, it's got lots of notes for the teacher, the educator, or the parent, which is great. And I also have another Elementary Globe, What's Up in the Atmosphere, Exploring Colors in the Sky. So another thing that you do as part of the cloud observations is note what color is the sky. And that's sort of a qualitative indicator of air quality. Like a deep blue versus a very milky sky, which may have a lot of aerosols in it. So I'm going to ask the question. Whoever puts their hand up first. Shelley, you're going to be referee?
I can be referee.
All right. What does the acronym GLOBE stand for? Yes?
Global learning and observations to benefit the environment.
Yes, excellent. So you, so when you want to, you can pick whichever book you would like.
Okay.
All right. And don't put your hand up till I finish. Can NASA see mosquitoes from space? I saw,
No.
yes, that's correct. Name 2 potential mosquito habitats. Shelley, who was it?
Tam had one.
Burrito.
A,
It was instinct, right?
Yeah.
You gotta yell at me
Tire
like
and
I'm deaf,
drain.
because I am.
Tire and drain.
Hmm?
A tire and drain.
Yes. All right. What do the 4 Globe Observer citizen science tools or projects have in common?
It's an essay question.
That's a little bit tough one. Charlie?
All the training that you need to access the process and participate is all included in the app. So you
Okay.
can just participate whoever you are, whatever you have.
That's true. And is there another answer as well? There's several things they have in common.
They
That's a good
also,
one. And you're correct, you get to pick a prize.
does anyone else wanna?
Okay. The other thing is they all complement NASA's space view of the environment. So, folks who won, I've got the books up here, come and claim your prize. I guess is there time for questions, or would
Yes.
you like me to move on?
There's time for questions.
All right, and if there are questions on mine, Carla, if you could let me know.
see any a minute ago, but I'll pick
I was
first.
gonna ask, it was sort of
Oh.
related to
Well, is
the
there
anecdote
anyone that
about
you guys do
spraying
teach?
mosquitoes and
I
finding
elementary
observations.
stuff? I do elementary.
But
I'm
really,
open
the anecdote
to
about
whatever's left.
spraying
I'm
mosquitoes
cool.
resulting in no mosquitoes in the experiment.
Is anybody
but
burning to
I know
have
there
this?
are
No.
Because you
experts
can.
Go,
which
take
have
it.
sprayed
Okay.
more
For
recently
Oh, God.
done
I have all the
genetic-
other stuff.
Sorry.
no worries. Have done genetic manipulation of
Yeah.
mosquitoes to
Yeah.
reduce populations.
Yeah.
Have you seen like indoor data, those effects?
You
Or-
know,
Let's
I'm
turn
not
around,
an
hold it up.
expert on that, but one of the
Yeah, thank
entomologists that we've worked with in Texas.
I think
is
I'm going
working
with
on
the,
exactly that
comic
thing.
book.
So
Yeah, that's
I don't know the answer,
Thank
but
you.
the people who write, they're working on
Kim,
that.
turn around, hold it up.
It'd be interesting to see if
There you
that
go.
shows up in the globe observations at some point.
Are we
That could be a good study.
getting other questions, or are we?
Any other
I'm like, I'm trying to stay away from Bobo.
Alright.
see you.
Angie's got her hand raised. Hey, Angie.
Sure,
Charles.
yeah.
I have some of them in Spanish.
Hi, I just want to say, I've done this with students before, and I cannot stress enough how powerful it is to have them, when they do this mitigation part, right? And they empty those artificial containers of water, that I just want to point out that I'm emphasizing what Teresa already said, that they're doing stewardship and they're benefiting their community. And so they can feel like they're making a positive change just by collecting the data. And I think that's really neat part about the mosquito protocol or the mosquito tool.
Thank you, Angie. Great point.
So we can,
Are there more questions before we close up?
let's thank Teresa for being here, coming here. She will also be here with the Share-a-thon, so we can do some more hands-on looking at her stuff. And I just want to put in your brains here, if you're a teacher and you work with learners anywhere, Funding Friday. Stay over on Friday. You can apply for up to a $3,000 grant. And we need to use ESIP tools, and these are ESIP tools. So as you're seeing these presentations, be thinking about, could I use this with my learners? How would I use this with my learners? What sort of infrastructure would I have to build that I need to use money for to do this with my learners? And we'll talk more about Funding Friday, but I want to direct your note-taking to, I could do this, And we'll hear from some of the people who have gotten a Funding Friday grant later on. All right,
Okay. So we have Funding Friday ideas coming up. And now we have Angie Rizzi, will be giving us a presentation and maybe interactive. Angie, I have I don't know if you can see me, but I have the data literacy cube templates. So I was gonna pass those out while Angie gets started. Let's make sure you can share your slides and you can take it away. We can see your slides. It looks great.
Thank you. So again, I'm Angie Rizzi. I'm from NASA Langley Research Center, and I work for AdNet as contractor. I had a colleague who was supposed to be there in person today, and unfortunately, she was not able to make it. So I'm really glad to be presenting this information and sharing it with you. Unfortunately, I won't make the share-a-thon, but I'm super happy to share this. And I'll go ahead and segue for the Funding Friday that if anybody wants to try to use some of these resources, please feel free to reach out to me. I'm happy to help. My email is in a couple of different places. So I was just going to start off with, how are you feeling today? Which Earth system sphere do you feel most like? Atmosphere, like your head is in the clouds today, or maybe you're growing like the biosphere, or grounded, such as the geosphere, flowing ideas like the hydrosphere, or feeling cool and confident. And I bring this up because just like Globe, the MyNASA Data website is organized by Earth System Sphere. And this is a cool little icebreaker that you could do with students as well when you're talking about Earth system spheres. So just wanted to throw that out there. I think today I'm geosphere, very grounded today. So I am the task lead for MyNASA Data, and I'm going to be introducing the website to you today, also showing you one of our most popular resources, which is the Data Literacy Cube. And then I'll give you a peek at our new visualization tool. So, Teresa made this really great connection between the fact that her tools are all citizen science and people are doing these ground-based observations, and then they all connect to some NASA satellite data. And we all know that NASA studies space, but sometimes people don't think as much about how much NASA actually studies Earth. It's our home planet, and it's the planet that we study the most. And so these are the major topics in NASA's Earth System Observatory, which is what we kind of call our whole suite of Earth observing satellites. And so you notice clouds, convection, and precipitation are big. Think of that as, your weather type observations. But also things like clouds have, some of them, believe it or not, have a cooling effect on the planet, while others have a warming effect. So they're very important to study. We also have aerosols, which has a lot to do with air pollution, and also some have a cooling and some have a warming effect. And then we look at things like mass change. And when we have large scale mass redistribution, that can reflect things like changing water tables or changing ice formations, things like that. We also have surface biology and geology, things like vegetation health and some of that habitat type information, and then surface deformation and change. And so we're studying a lot of different things about Earth. And we have this suite of satellites, and I believe this visualization here is from 2023. And you can notice that the different satellites have different orbits, and think about the fact that these different satellites have different instruments on them. And you can think of the different instruments as things like our different senses, right? They're measuring different things. So the satellites even complement each other. And then ground-based observations, airborne observations, citizen science observations, what balloons and other things are going to complement these measurements. And MyNASA Data is a website where we take a lot of the satellite data and we curate it into content for teachers and students. And so you see here on this slide, we have the different spheres of the Earth system along the top. And we also have Earth as a system. One difference between MyNASA Data and GLOBE is that we have the geosphere where GLOBE calls it the pedosphere. It's basically the same thing. And believe it or not, MyNASA Data is funded through science activation, like Teresa mentioned, through a project called Globe Mission Earth. And so on our website, we also have connections to GLOBE. So we have the different spheres and we have different phenomena in each sphere. And these phenomena have 3 different types of lesson plans, which I'll cover in a minute. And all of that content is aligned to the next generation science standards. So if you have particular topics of interest, you can find them on our website. Here's a little bit more information on the mosquito habitat mini lesson that Teresa mentioned earlier. Our mini lessons are short and they're student facing. Certainly a teacher can always use any of these lesson plans however they want to, but they could provide students a link to the page and the students can do it. And on this mini lesson, they basically have 2 climographs for the same longitude, but different latitudes, looking at Memphis, Tennessee, and Moline, Illinois. And the students just answer questions about when they think mosquitoes would emerge. There's some background information to help them. And then they also answer questions like, well, what would happen if the temperatures increased by 2 degrees in these locations? So that's a kind of a quick type thing. And that's what a mini lesson is. Quick student-facing activity. Then we have what we call interactives. These have some sort of component where the students can digitally interact with something. The one that we felt was probably more closely related to mosquitoes would be this interactive weather observations. And in this activity, they have slides and they're able to actually take the color bars, the color boxes under each sort of bar chart, and as they track the weather over time, they can drag the bars up and sort of build their bar charts. Sort of like a digital version of doing this with Legos or Duplo blocks or something like that in the classroom. There are also versions in there where we have Celsius and Fahrenheit temperature tracking, but it's something that they can build out the bar charts themselves. And then a more complicated type of interactive that we have that's longer are what we call our story maps. Our story maps are all written in a 5E model, and they take they can take up to a couple of hours for the students to get through. But think of it as almost like your whole implementation for a topic. So hurricanes as heat engines is one of our most popular ones. Also, our urban heat island story map is super popular, but as you can see, the 5Es go across and the students are able to interact, and there's GIS technologies, so they have different sorts of interactive maps and data in these. So that's super exciting as well. We also have lesson plans, and the lesson plans are teacher facing and they can be varied length. We have one that's called Analyzing Data for My Location that walks you through how to use the Earth System Data Explorer and pull some data for your location. And the Earth System Data Explorer is our visualization tool, and I'll be showing you that in a minute, but just for you to know that there is a lesson plan on how to use that. Okay. That's the tutorial, and I'm not going to play the whole tutorial now. So on our landing page, again, we had all the spheres. If you hover over a sphere, the phenomenon will drop down, but we also have some additional resources under the Resources tab. And the most popular resource that we have is our data literacy cubes. So just to confirm, did you all just get a one-page template that looks like what's on the screen here? Okay. So this is the template for the cube. And if you notice, each face of the cube just has one word on it. And so what we did is we made questions that go along with each of these words. Okay. The questions are leveled by the students' Lexile level and their WIDA proficiency level, which is basically their English, in the United States would be their English proficiency level. Okay, so we had a dual certified teacher, certified in science and ESL, who helped us with this leveling. Okay, and so we have different types of questions for different types of data, and that would be mapped data, line time series graphs, or like a data table. Okay, so there are 3 types of questions: maps, graphs, and data. And for each question type, we have the 4 levels of novice, developing, proficient, and advanced. All right. And we're really trying to get at the same content in all 4 of these levels, but we're asking the questions in such a way that the students can understand the questions based on their language abilities. Okay. So we're not necessarily asking about different concepts about the data. We're just asking the questions using different words. Okay. So what you don't have in front of you is that there is an entire guide that has, 4 questions for 3 different types of questions and a implementation guide and everything else. And you can access that for free online. The other thing that these questions have is most of the sheets, except for the advanced, have keywords. And the keywords at the top of the sheet are not a word bank. They are not words that the students use to fill in the answers. They are words that the students need to understand the questions. Okay, but this helps them develop some of their vocabulary. Some of these words might be on a word wall if you choose. It's just all depends on your class. And there's space for them to add additional words. The sheets are not intended to be used as a worksheet. Like, they don't necessarily have space to fill in all the answers on the question sheets, just so you know. So you'll need to figure out how you want to manage that in your classroom. And then we also have task cards where we have some different job names that are like NASA type job names to help the students work in groups if that's how you choose to implement it. And there are also opportunities for students who may be nonverbal or have limited language abilities that, they can be the one who rolls the cube or that type of thing. So we're trying to make this as inclusive as possible. So for your differently abled students, especially if we're using the mapped data, you may want to consider them having a magnifying glass or a tablet where they could magnify the image, or printing on 3D or Swell Touch paper if you want. I will tell you exciting news that we have an intern this summer who is working on making one of our sets of mapped images available for 3D printing as well. So we'll hopefully have that in a few months. Okay, so how do we use the cubes? Since I'm not there in person and I couldn't walk you through it, I'm gonna try doing this virtually. So I pulled, because we had that mosquito habitat activity and we had Memphis, Tennessee. I pulled some monthly surface air temperature data for Memphis for a few years. So if you want your students to look at this, you can give different students different question levels. So we're just showing here the map, the cube, and question level 1, but I broke them out separately. So let's assume that they rolled a 1, okay? Then notice here that the questions about this graph, if they were to roll a 1, is the information on the graph shows, and then notice we're asking about what do the horizontal and vertical axis represent. And these questions are all about the horizontal and vertical axis, okay? If I move to the level 2 questions for the same thing, they rolled a 1 on the cube, but now they have the level 2 questions instead. Those questions are asking them about the X and Y axis. And there's even a little picture over here on the side, kind of prompting them, which is the X, which is the Y. If you move on to level 3, now it's the independent and dependent variables. And you notice the little picture on the side has changed, where instead of labeling it X and Y, it's labeling it independent and dependent. And so they're accessing this, and this is combining independent and dependent with X and Y also. And then when you hit the advanced level, we're saying the variable represented on the X axis and Y axis, and what is the range? And so and we don't have sentence starters for them. They have to complete it more fully. So maybe I can pause there for just a second and see if maybe with a show of hands or a thumbs up in the chat or something, if people feel like this would be helpful to you in your classroom. Okay, I'm seeing a couple of hands, so that's great. So that's an example of some graph questions. We also have questions about mapped data, and we also have questions about data tables, okay? So you might wonder, where can I get these maps and these graphs and the data? And so we have a visualization tool. We also have a set of mapped images for 2021 that are available. And it should be linked in our resource document that we shared. So it's 6 different variables over the course of a year. And you can look at how, and we have 6 lesson plans written specifically to use those cards and the cube. And that's all great. And I'm happy to share that. But the way to find visualized data is from our landing page. You click on visualize data, or if you hover on it, it's the Earth System Data Explorer. And I am going to go ahead and link out to it. So can you see my new screen that just came up?
Yes.
Okay. This is our new tool. Now, I'm being fully transparent with you that we just released this in May. We replaced our old tool. For those of you, I know at least one person in the audience who's probably seen it before, the old tool. So if you find a little glitch in this, let us know, because it's pretty new, okay? But this is based on Google Earth Engine. And when you come in, it's going to load an empty map. All right. And then I'm going to choose a sphere of the Earth system. So I will choose atmosphere. And then I'm gonna choose a category. I will choose temperatures because the monthly surface air temperature is our most popular data set. So I'll choose monthly surface air temperature, and then it's gonna ask me to pick a month. I'm gonna pick July of last year. It won't have July of this year yet because these data are not real time. They're typically at least a few months old. And you see that the legend loads, the mapped data are there. I can zoom in and out. You know, I can see the whole world here. I can zoom in so far that I only see one data pixel and it's just one color. So like if you typed in your address, it would just show one square. I'm trying to get back over to the US now. Okay. So this is great. You can download the images. You can screen print them, different options, and then you can change your time frame, right? If I were to change to January, it's a completely different image, right? What I really, really like about this is that you can zoom into your own location, okay? The other thing you can do is you can click on this identify button and you can probe the data. So if I click on a location, it will tell me the value and the latitude and longitude. Okay. So that's another really cool feature. Okay. Now, every time I exit one function, it likes to go back to 0, 0 over by Africa. Okay. The other thing I can do is compare two images. Now, in our old system, we could only compare variables in the same folder. But in the new system, I can compare different variables. So I can also click on satellite. So now I can compare the data to more real color satellite imagery. Okay. Or to the map. Or I can choose a completely different time frame or a completely different variable. So I could compare temperature and incoming solar radiation, or I could compare temperature and clouds, or vegetation and precipitation, you know, different combinations. And I can do this slider to see the comparison of the two. Okay. So if instead I pick monthly flow into the surface by shortwave radiation, which is, well, I see that only goes up to June of last year. We can compare different variables as well. Okay. So that's a really exciting thing to be able to compare different variables, which we did not have the capability to do, or to compare to the satellite imagery. That's a really neat feature. Then we can do, and I do want to come back here, a time plot. So I'm guessing you guys are sort of around there. I can just click on a location, or I can enter in a lat long. Am I even close to where you guys are?
You're a bit east.
I'm a bit east.
And go to the white.
Better? Little south now? Anyhow, and I can specify my starting and ending times, okay? And it will generate a line plot, which if you if you keep it in this view, you can look at each value on the line plot. You can also expand it and download this image, okay? And if I click on generate table, see, it puts the table up above. And when I expand that, give it a minute. And sometimes it takes a minute to generate the table too. It will pop up with an option to download the CSV file right here. And you can download that file to your own machine. And then you have the file ready to use. You can bring that into spreadsheets, tools like CodeApp, whatever you want to do. Okay, so what I thought I would do in the little bit of time that we have left is give you guys an opportunity to explore this. I know it's a little hard since I'm not there in person, but I'll try to answer questions if you have any questions. So the easiest way to get there is going to be you can just Google My NASA data, go to the website, click on visualize data, and you'll be in.
Angie, I put the link in the Zoom also.
Thank
right?
you. That is awesome. I appreciate you for that.
So Angie, can you talk a little bit about the sources? Some of them over to the left, like I took surface air temperature and I see sources Miratune.
Yes.
Right?
Yes.
But then I picked a different thing in my compared to, and I'm not seeing, oh, it says GPCP. So is there a place for me to know what those are?
Well, we do have on our website, if you go under visualize data and you go to our data collections, and then from there you go to our citations page, we actually have citations for all of our data. We are working on more friendly language, which is probably what you're looking for. Like,
right.
you know,
So the table, is it all NASA data or are there other contributors to the data that's being presented here?
it's mostly NASA data. We have maybe a few things from NOAA. And then we do have some other modeled data from some respected international sources as well. So it's all publicly available. The one thing that's nice about these data though is that they're from reputable sources, right? It's NASA or NOAA or like a government agency where we're vetting the data. And that's part of the reason why we don't have real time. Because these data have been vetted before we publish them.
That's probably why you have the lag, correct?
Yes, and the other thing is like most of our data are monthly. And so there's some processing that goes on to take all the daily data or even the hourly or whatever, right, and make it into monthly data. And that though makes it more accessible for people because otherwise the data sets can just be far too big, right? So there are some questions where the monthly data are not as helpful, like especially on things like air quality, right?
Right, yeah, and I was thinking the water temperature, or the air temperature too, like I would use the daily, I would be interested in what the daily is, or even, I would probably look at a real time. But
Right.
I have a suggestion, and I don't know if you talked to anybody, and there might be something, but in your source there, I mean, you do have the source, but if you could link that to that very nice table with all the citations, I think that would be really helpful. And if it's a third party, like not NASA, it'd be really nice if you communicated that on this page and to say, source and then also, agency. Because I think that's really important to who's collecting that data and supporting those networks.
Sure. Okay, that's awesome. And we are doing some work that fits in with really well. So I love that suggestion. And surface air temperature is one that we have daily data for, and we also have daily data for sea surface temperature. So in fact, if we go and look at our data collections, I mean, we also have yearly, but we have daily clouds, daily air temperature, daily sea surface temperature. That might be it. Right now, we have over 60, we have daily precipitation too. We have over 60 data sets, and we will be adding more. But we also look at the data usage. So we used to have over 100 data sets. And, we had some that had like 3 people looked at it for a whole year or something. So, if we aren't getting usage on it, it's a lot for us to maintain it. So we do sometimes call out those that don't have a lot of use. Does anybody need help accessing anything?
Looks like most of the participants are working with it right now.
Great.
Hey Angie, I have 2 questions. This is Vicki Gorman. How are you?
Good. I was just going to call on you anyhow.
Okay. So, and tell you how wonderful this is and how when it first started to where it is now is like amazing. You guys have done an amazing job. 2 quick questions. Where you showed us the graph and you had the leveling for differentiation. Do you also have maybe in the works where students can start at level 1? Or maybe it's designed for that already. But like I put all my class at level 1, they do level 1, those that get done quickly can go to level 2, rather than me telling them where to start. And then those who feel comfortable go to level 5 or whatever it is. Other students may stay at level 3 because they haven't really learned that yet. That would be really helpful because that's even an additional way to differentiate.
So are you talking about using with the questions themselves?
Right, so what I would look for is either they would use the same data at each level, like the same graph at each level.
Yes,
They would
yes,
start at level 1 and then the questions would just get more difficult.
yes. So I
Or,
think,
go ahead.
well, so we haven't written up exactly telling the teacher how to do that progression because it's one of those things where I think different teachers will implement it differently. So the teacher themselves can say, I'm giving this group level 1 and this group level 2. And also the level 1 level might be more like a, elementary level, right? And then the advanced might not be advanced high school language proficiency, right? But, and so absolutely, I think you could implement it in a way where you let the students decide their own progression or you decide for them. But the intention is like, yeah, they might all be looking at the same map or the same graph and using the different questions.
Okay, because for me, it would be wonderful if I said to students, start at level 1, and then they go to level 2, they didn't get all the answers to the level 2 questions back in level 1. And then by the time they work up, they're at a whole new level of analysis, which doesn't use all the data from before, so they're making new smart observations, using better critical thinking skills, something like that.
So what I'm hearing is potentially leveling it not just by language ability, but by, say, data literacy skills or data analysis and interpretation concepts.
Exactly.
So, we don't have that yet, but that is very much, on my radar.
And then I have a quick second question.
Sure.
Going to an ESIP conference is like taking a safari for an educator, okay? So yesterday I'm hearing all about NOAA working with data in the cloud and making the information more available to industries so that it's so user-friendly, they just go in and they can hit a button and get a visualization and really be able to, the end user does not have to be literate at all in the data. They can just follow it and then make decisions about their company. I was wondering if NASA is working with NOAA at all, and I know how we are with sometimes in our own little silos, but I was wondering if NASA and NOAA were working together to bring that sort of ease to education, because otherwise education falls behind the power curve again.
So I don't know if NASA and NOAA are working together, but I know that NASA has a lot of efforts around open science and trying to make things more available. And there are other options at NASA besides what I showed you today. There are some other tools. And what we have found with MyNASA data compared to some of these other tools is that as much as we're working on making the data available, when it comes to the download functionality, sometimes you do still have to be an expert to get the NASA data. And whereas you can get it from us in a CSV file. Or you have to be an expert in all the missions to know which file to even select, right? So we've gone through that and done a lot of that heavy lifting and said, if you want to look at temperature, look at this. But NASA's working on it for sure. And then there is the Earth Information Center, if you're interested in a lot of visualizations and that kind of thing, where you can you can actually get some more current information there. You're not going to be able to download the data, but you might be able to see a visualization or that type of thing. So does that help at all?
That does. It's just I always see so much great work going on in all these different spheres, just like Globe. I don't know why you guys and Globe don't even work more intimately together, especially since Globe is NASA funded.
So under the resources, we have a lot of Globe connections in MyNASA data. And we also, under each sphere, if you see the phenomena, and then we also have Globe connections just for each sphere. And you can pull those up and it'll tell you like which data of ours are complementary, and then different topics within Globe, the elementary Globe like that Teresa mentioned, what Globe protocols there are for that sphere. I mean, we do have a lot of Globe connections in MyNASA data. And what I would say that to keep in mind between those is that Globe is that user collected, right? Student collected primary data. And that's how they initially begin to learn and become and understand data, is when they collect it themselves. And then MyNASA data has large professionally collected data sets where our lesson plans and mini lessons and interactives have taken that professionally collected data and curated it down into sort of something in between, something like Globe, where they collect their own data, and just going into the visualization tool and having access to all this professionally collected data and sort of exploring it yourself, right? Then the lesson plans in that are that curated data piece in the middle.
So that's the best explanation I've heard in a long time about how the two can meet. it would be great if on Globe's website, and they might, I haven't looked at all of Globe's website, but if they also had an explanation like that and then led you to MyNASA data in each individual, protocol as well. But that was great. Thank you so much.
Sure.
And Angie, I'm just going to interrupt and ask for any final questions or any final words that you'd like to pass on to our group. Real quick question over
I
here.
have a quick question. Maybe you could tell me in regards to when we have students that use iPhones and two professionals right now that sadly don't have a laptop with us that's working properly, but we keep coming up with an error on your website that says something went wrong while displaying this app. Please come back later. And I can tell you that from a student's perspective that they will become highly agitated.
Yes.
And then sadly, I don't know if it's just the website itself, but I've tried to go through exactly as planned what you have on your display there for going to Atmosphere, and then and I took a screenshot of it as well, just so that, but I did exactly as what you said here, but sadly, we only get this little tiny block in here that is just a quarter of the screen, and then it just locks and tells us there's an error. So I was just curious if you've had that experience before with the phone versus a laptop or an iPad or computer.
Well, I've gotten that same error even on the computer when I was trying to change something. And we're working on fixing that bug right now. But I can test it on my phone and see if it's the same problem. Because yeah, it's working on my phone. But what I have found is that once I do something over there on the right-hand side and then try to change, sometimes that error comes out where I think there's something wrong where things aren't getting cleared out. So we're working on fixing that. So I would say, I know students aren't going to like this, but for now, like, get out and start over and see if it works. If it still doesn't work, send us an email and let us know like what kind of phone you have or something. Because maybe it's your operating system or your version of.
Yeah, we are all troubleshooters as we move on.
Right. So I guess my final parting thought is that we really are here to help. And my email is in there. I will put it in the chat as well. And I will answer emails. And I'm happy to meet with you more, meet with you personally, meet with your department, your school, your district, anything you need. We're here to try to help you. You pay your taxes. Take advantage of the help.
Thank you, Angie. Okay.
Thank you.
Okay, well, next up will be Jessica McKay, and I need to share hosting privileges with you. Let me go ahead and do that. And I've made you a co-host so you should be able to present. Jessica is with USGS, and she has a really cool project to talk about using USGS data in the classroom. Jessica, can you hear us?
Yep. Can everyone hear me?
Yes. So take it away.
Awesome. Well, hi everyone. Sorry I couldn't join you in person, but I'm really excited to present to you, even though it's online. I'm Jessica McKay. I work for the USGS Water Mission Area as a science communicator and also the Water Science School product owner. The Water Science School is basically a one-stop shop place to learn all things water science. And we have different activities available for teachers and also a variety of lesson plans and ability to order posters and other fun things for your classroom on that website. But today I'm not directly talking about the Water Science School. I'm going to be talking about a CDI funded project that myself and our large team here listed below were funded to do. And it's all about bringing USGS data in the classroom in a pretty unique way. So our goal in this project was to really enhance and expand the reach of accessibility of USGS data and science into the community of K through 12 students and educators and even their families. For this specific project, we really did a pilot program to create interactive web applications. And we kind of focused on two different subjects based off of the expertise of our project team. So we have an app developed for urban heat island effect and also Streamflow. Today, I'm going to be talking about the Streamflow app directly because my expertise is water, being the Water Science School product owner. So I'm just going to do a short presentation and then we are going to actually put the app in your hands to kind of play around with. So how did we create these apps? So first we wanted to develop interactive lesson plans using already published USGS data that's pretty hard to access and understand. And in these lessons plans, we really wanted to align with the NGSS teaching standards. Also in this interactive web application template, we wanted to establish reproducible templates. So be able to have code that could be used for a variety of USGS data, not just urban heat islands, or in this case, Streamflow data, that's easy to kind of create yourself as an educator, along with having some tutorials on how you can put your own data into these apps as well. In addition to this, we coordinated an in-person workshop where there was an opportunity to work with educators, a group of 20 educators, to help refine and develop this application, and then ultimately share and expand the resources and results, which is part of what we're doing here today. So to do these apps, we used R Shiny. So R Shiny is an R package that provides a pretty easy and powerful tool for building web applications using just R. So in some applications require expertise using HTML or JavaScript, which are typically more complicated in R. We really wanted to simplify that process. So what you will be playing with in a minute is actually an unreleased version of the app that is still undergoing development. So we're still in the beta process of it. So during the teacher workshop that we held about a month ago, we also asked them to play with the app and give extensive feedback to make it better for educators and show how it can actually be put into the classroom. And so at the end of this activity, we're going to provide a link where you all can also put your feedback that will be included in the development of this app. So again, this is just the beta version of the app that we're continuously refining and developing before we can release it to be used in the classroom. I'm not sure why my apps are going before I'm clicking. And then again, because this is a shorter, I think we have about 20 minutes today to talk about this, some of the parts of the apps are going to be different to navigate than it would in a classroom setting. So I'm just going to kind of go over that as we go through the app. So here's the link to the application. I will say, I know someone said they only have a phone available. It is a lot easier to work with on a laptop right now. So if you don't have a laptop, I would recommend partnering up with someone who does have a laptop so you can get the full experience. But it does work on mobile. It's just kind of harder to navigate that way because it's an R script. So once you navigate to this app, it's okay if you're not on there yet. I'm going to re-go over all this, but I just wanted to show how we're reforming the app for the purpose of this workshop. So this is what the app looks like when you get into it. There's going to be a password that you type and it gives you the password water. So you're just going to type water to be able to access the app. So it starts off with just asking you to think about the following questions and you can write a short response in order to continue on in the app. And this is the part that's really changed because we're not in person. So in the teacher workshop, something important about this lesson plan is that we really want to encourage students and educators to go outside and explore the natural world around them. So the first part of this activity actually includes going out into a stream to collect some of that data. And the videos we have here are what that activity looked like. Unfortunately, due to timing, we can't do that full activity. So you're actually just going to click this download activity workshop worksheet and then move on. So also in that, because part of the app activity includes inputting your data that you just collected into the app, in order to refine that for those who can't go outside, there's an additional step that you can complete, which is actually visiting the USGS National Water Dashboard, and we'll provide the link for that. And in that, you're going to navigate to stream gauge nearest to your current location, or you can even do your hometown location. And then once you get to that stream gauge, you're going to see that number you can input to continue on with the activity. And then you're basically just going to go through all 4 of the activities on the make a prediction sheet. And if you have additional time, we really want to encourage you to explore the USGS National Water Dashboard further. I don't think we'll have additional time for that today, but it is a resource that is super helpful. So yeah, if you just want to navigate to the app, that would be great.
It's in the chat, if that helps you.
In the chat, in addition to the Streamflow app, I also included a link to the National Water Dashboard that you're going to need to find that number to put into the app. But yeah, I really kind of want this to be you go through it rather than me showing you guys exactly what to do, because one of the things we are really working on is improving the user interface. So any problems or anything you struggle with, of course, you can ask me here now, but also include in the feedback form if you have a chance to fill it out at any point during the workshop.
Wait, it's it auto, it should be R connect, there's mine. I think it's just R connect, I don't think there's an E. I know mine it auto corrected.
In the URL.
Yeah,
It literally says RE.
I typed that in and it auto corrected.
Yeah, it should be R Connect. R
It's just
Connect
R
is a,
connect.
yeah.
Sorry.
I know, it's, you're like, please don't help me,
Yeah,
computers.
please,
Yeah.
that's not what I typed.
Yeah.
Yeah.
Yeah, but it thinks you wanna.
There you go.
Okay, thank
Okay,
you.
sure.
It literally says RE. It literally
I
says
did,
RE.
I know, because I typed it in
Oh, okay.
and Google corrected it for me, so I just fixed it, yeah. And the password is yellow.
This is the shot there.
Okay, Jessica, people are messing with it. It looks like everybody is connected. If you're not connected, folks, just do a shout out.
So Jessica, this is Kim, I'm with the USGS. I was in the restroom for your first 2 minutes. Is this through like UCAR? Who's working on this project?
Yeah, so it's actually all USGS employees at the moment. So this was funded through the Community of Data Integration. They have a grant program that they run. And so our team is comprised of multiple R developers, most of those being from the Water Mission area, in addition to having people from the Pacific Island, CASC, which is the climate adaptation centers. And then in addition to that, we also had a Albert Einstein fellow, Sarah Slack, participate on this project as well.
Thank you.
Can I ask you how you get to your next screen here?
It doesn't.
Let's see. It's because your answers are wrong.
Might be.
Good job, now put things.
Oh, you gotta scroll down, okay. Thank you.
So Jessica, for the CDI funds, were they from last year or do you have funds this year too?
So it's the current fiscal year. So this project kicked off in March. We have a pretty short time window. The project kicks off in March and the funding ends in September. So we've kind of been spending the time building the beta application in addition to holding a co-production teacher workshop the beginning of July. I thought it was last week, but I think that was 2 weeks ago.
It all kind of runs together, right?
Yeah.
Might consider adding pictures in. I don't know how easy that would be. Like I'm in the flow rate activity and it's talking about flow rate and then let me go to the previous, okay, so I did that one. Yeah, so maybe having a picture of, showing like a buoyant object in the water surface and.
Yeah, so the flow rate activity, this is the one, I don't know if you were here at the beginning, that they said that we're skipping because it's actually an in-person, go outside, go in a stream and collect your own activity, like collect your own data. So that's a big part of all of our lesson plans is that there is a part where you're collecting your own data. And so
Might just be nice to have a picture on this page so people can kind of visualize what they're gonna be doing.
yeah, that's a great idea.
What did you skip?
I skipped it. It was a just being downloaded worksheet.
Yeah, okay.
Okay, and then on the worksheet, there was this group.
That's where I'm going. Okay.
Is anyone struggling at any point in the application?
Jessica, I've got a question for you. Where is the data coming from for things like the dashboards, National Water Dashboard?
Yeah, so you're talking about this dashboard? So the data comes from a variety of places, most of it being USGS stream gauge data. That's the large focus here. So a lot of these dots here are where the USGS has stream gauge locations. So they're collecting the physical data that's being transmitted to this online dashboard. There's a few other layers, such as like weather conditions, so where I think we work with NOAA to get into some of that data in there, but the rest is being collected at USGS stations. And there's kind of a legend where you can see where each of the layers are being collected.
So we collect usually 15-minute data. And so every 15 minutes, and that gets sent by cell or satellite, and it's a gauge height, and then we go out and measure the stream flow, and that gauge height coordinates with the stream flow when we have what's called a rating curve. And so once we have the gauge height level, or the height in the river, we coordinate that with this stream flow value, and that's where the stream flow data is coming from.
So it's fairly real time then?
It is fairly real time, usually updating every hour. Used to be every 4 hours, it's now every hour. But we also have like other data sets in there. If you click on the USGS stations, there's groundwater levels, spring water levels, water quality, precip gauges, atmospheric and so forth, data sets we have in there.
Are you guys linked with, and I know I was in the bathroom, but are you guys linked with Globe at all?
I don't think our data goes in Globe, I did not see it.
Okay,
So this is all, like, we hire people and those people go and do this work. It's not a citizen science group.
okay,
It is paid people, and though USGS water mission area is a little different, we're not just getting federal funding or appropriations, we also work with partners, local partners, and a lot of the locations are driven by what the local partners want.
Need, yeah.
Right, and need. And it used to be, it had to be another agency, like a state agency or a county agency, and that's not true. Like, McDonald's could come in and say, hey, we want a gauge here, because people come in to kayak at this location. We want a water temperature sensor there.
Is there a way for students or teachers to find out what local industries or businesses have maybe requested this information so that students can actually go out into the community, talk to these business people and
Right.
figure out how data is being used?
Jessica, can you go to, open up NWIS? You can just click on a site in, I think Texas and Ohio have it. If you click on one of these sites, oh, that's droughts. If you click on one of the sites, you should be able to go back, Jessica. Go back to dashboard. Can you hear me?
Yeah.
Okay, just keep zooming in. So you get to like a site in Ohio. So to the right.
I do want to say we have about 4 minutes left. And while
So yeah, so if you go to, click on one of the dots and go to open it up in NWIS, NWIS will have, most of the sites will have who our partners are for that site at the
great.
top. And then some of them have cameras at it, which is super cool. And as an educator, you might be interested in that as well. There's a HiVis network, which is HIVIS, which you might be interested in as well. And that shows all the 500 to 600 cameras the USGS has on the streams and lakes.
Because it would be great for the kids to travel to a McDonald's, and
Right.
talk to the business leaders and
That-
see other ways that science is interwoven in case people don't maybe want to become a hydrologist or
So forth,
right,
yeah.
yeah.
And I think, I would say we're still at about 98% of our partners are probably an agency, but there are some out there that are not.
Cool.
Yeah. Sorry, Jessica.
And Jessica, we can go a little bit longer if you want. Our lunch starts here at 12:30, but we don't have to get there right at 12:30. There'll be a line.
Yeah, no worries. I'll just give you guys about 2 more minutes to play with the app, and then we'll just come back together to talk about it, and wrap things up. There's so much, as we just heard, there's so much data in USGS, and it's hard to navigate, especially for a classroom setting, on what can be used and what can't be used, and how we can bring this to educators in a more simplistic way in these kind of package-built applications or lesson plans. So yeah, this is just one example of how data can be used. This is really why we're trying to build templates where we can pull some of that other data and build different activities around it.
And our most favorite actually access site is Water Science School with the USGS. And there's all sorts of educational teacher resources for water education, water cycle diagrams.
Yeah.
Yeah, that people
Yeah,
might
so I
be-
included that link in the resources. I'm actually Again, I don't know if you're at the beginning. I'm the water science school product owner, so that's where we're planning on hosting all these applications as well. Okay, hopefully you all had a chance to get through at least some portion of the app. I know there maybe not have been enough time, but I kind of just want to bring us all back in to kind of just talk about things you've noticed, maybe improvements you would like to be made, maybe some things you liked about it or things that could be added on. So I just want to open up the conversation and start off by, is this something you think that could be used in your classroom?
Go back to your original screen.
Or how might we use this with learners? How?
You could take the satellite information from GPM, the precipitation mission, monitor rainfall, and the kids can actually take the measurements, and then see how that affects stream flow, and then tie that into flash flooding, flooding in your area, then tie it into the weather event that caused it, look at the GOES data for that. I mean, there's a lot of different things you can do.
I like that tying it to the local region or where it is, because we always want to make it relevant.
Yeah, the stream flow activity was a great activity, and I downloaded the whole workshop worksheet for that. Also, you could look at water quality, you could look at stream flow and, the larger water cycle resources that you have in here as well, and using the data around the topographic maps and water sources and things as well.
We do an activity, it's usually the first Friday in October, and it's called, it's run through the DEC, I can't think of the name of it, but they take all the schools in the county that we belong to, and a local education center has what's called these basin bins, or these 33-gallon totes. And they have waders in, and they have plankton nets, and they have everything you could imagine to quantitatively assess the health of your stream. And they send schools out to every stream in our county. And it's always done on the same day of the year, and then all of the data is uploaded to the DEC website. So you not only have the data from all the schools, you have the data from all the schools from year to year to year. And we've been doing this for probably 10 or 15 years. And I think they were doing it even before that. But they're required to do things like looking at cloud cover data. We use Globe, and this would be a great application because we actually do have one site where we go to where the kids have to do the stream flow measurements. And we have our own write-up of how to do it, but this might be a better step, next step in the process.
Right.
That sounds like a really cool program. I wish I had something like that when I was a student. Awesome. Well, some other things I do just want to note before we end is that, again, this is just a super beta version of the application that we're continuously developing. Every day we're adding new things, and I really like the recommendation of adding more pictures. I think that would make it more visibly appealing and make more sense. But I do want to mention this for teachers corner. And again, it's still being developed, but something that we really want to do with this for teachers corner is be able to add an area where educators can actually customize the app. For example, if you're not able to go outside, you can cross that part out of the app instead of me having to tell you to skip it. And then you can kind of pick and choose which activities you want to include or not include. And again, that's the next phase for this app. It's not available yet. Is something like that useful for educators?
I'm seeing people nodding their head and, and I was also wondering for those who are in a non-formal classroom or not a classroom at all, you know, how could you implement something like this, like without using the worksheet, but still guiding people through a stream flow kind of exploration?
So I have an activity I do in one of my classes, and so what we do is we'll stand the class up, and you'll have each of them, like if they're younger people, we'll have them wiggle. But we'll have them like hold their hands like this, and they're like, you either going fast or you're going slow, right? And you go person to person, you go, we're measuring the depth, the width, and how fast they're going. And then we combine that into a stream flow measurement. So it's kind of, everyone gets up, they interact with each other, and that's kind of a fun thing. But yeah.
Do your hand wiggling high so people online can see that.
Yes, the wiggling of the hands, so yeah. Jessica, are there gonna be, like because this is, the exercise activity, are there gonna be statements on like we're a PFD and, they're going out in the streams and the USGS isn't, responsible?
Yeah, great question. We will have that. So as part of this whole package of lesson plan, again, this is just the application part. It's actually a whole package. So it includes a set of PowerPoints that do the introductions to Streamflow, and it also has a guided for the flow rate activity, like a safety teacher's manual part of it, where it has the safety manual recommendations, what personal protective gear, things to consider, and then that USGS disclaimer as well.
Then, if you have time this year, maybe an enhancement in the future is showing the high vis with all the, pictures, we think people would really like that, and then maybe a water quality site.
Cool. Yeah, and I think in the planning of this, again, like this is just one part of USGS data, but it would be to do a similar web application with water quality focused activity. So there would be in-person water quality, and then there would be a different set of online activities that you would do to address water quality.
Sounds awesome. Thank you for all your work on this and the team's work on this.
Yeah, thank you all. I don't want to keep you from lunch. I know that feeling, but I did just drop a link in if you want to provide any additional feedback. You don't have to complete it now. You can complete it at the end of the day during your lunch. You actually don't have to complete it at all, but we would really like to hear your feedback. Again, we're really focused on doing a co-production with educators to make this app really something that could be used and valued in a classroom. So any and all feedback you would like to provide would be awesome. But with that, thank you all, and I hope you enjoy the rest of the workshop.
Thank you, Jessica.
Or they probably could through your, but now we're good. Okay. Who's next? We have sound. We have sound now. Patricia, can you hear us?
Somebody online that can say yes.
Yes, I can hear you now. It came
Thank
back
you.
on.
All right.
My lightning talk.
Okay,
Thank you.
back on track. So another lightning talk person, why don't we just, instead of following any kind of list, a lightning talk person, jump up and grab, go. I got, okay.
All right, so I've got some of the resources I presented this morning, if you want to see samples of them. I have a beta activity, this is version 2 of it. This is a mystery pixel activity, it's a Landsat USGS NASA Landsat image, and each pixel has a letter. This is data, and I have the crayons and the key to color it in if you want to come color with me and give me some feedback. But this started as a tabletop activity to have at a conference to get people to come over and talk, and you can talk about satellite images and resolution and why doing citizen science helps to fill in the detail in some of these pixels. So come give me some feedback, come color, it's fun.
CSEP
has been
really fun.
Yes,
I love that
activity. Is there a map that they're trying to visually see
Yes.
where it is on the map and then
It's a satellite image that was pixelated, assigned the same color, and mapped it to the Crayola 120 crayons. So something that you can, it's accessible for coloring it in. Come and talk to me and I'll.
Yeah,
I love
absolutely,
it.
and I'll just pop in, if you have a question, this is the time when you say, I'm gonna go talk to that person.
Yeah.
Everybody's gonna give a brief intro of what they're doing, and then we're gonna scatter plot all over the place and move about. So let's jump over here to Keith.
You can share the screen.
Actually, I can do it without sharing, it's fine. Yeah, so my name is Keith Bryant. I work at NASA. I'm the lead UX engineer for something called GESDIS, which is the Goddard Earth Data and Science and Information Center. We are one of the 12 archive centers in the NASA Earth data ecosystem. But we're also responsible for creating something called Giovanni, which is a visualization tool. So on demand. You can just enter your constraints, date range, bounding box, point, and discover the variables or the measurements that you're interested in plotting, and plot those at the touch of the button. So we've been around for a while, continually evolving. Currently, we're moving into the cloud. We have a nice stable API now. It's very fast. We can do a 20-year time series of half-hourly data inside 10 seconds, which is really fast, especially compared to the on-prem, which I don't think you can do. You can only do 6 months worth of half-hourly data. So it's much faster, but we don't yet have a UI. We've been concentrating on the back end. So we just started designing a UI concept. One of the biggest demographics of Giovanni in terms of users is actually educators. We hear from educators all the time when something's wrong with Giovanni. It's like, Giovanni's down, I gotta teach a class. So this demographic, you guys, are especially important to us. So what I'd love for you to do is kind of give us some feedback on this conceptual mock-up. Tell us whether it's headed in the right direction, whether it's awful, what you'd like to see it do, all those kinds of things. And that's pretty much it. We'll be here. We have at least 2 laptops. You can, we have Figma mock-ups, so you can walk through them a little bit. I'll just ask you to think aloud while you're walking or while you're clicking things. Tell us what you're thinking, what you would like to see, just your impressions. So that's it.
And if I could jump in to help Keith, if we are unable to capture your thoughts, or if it's kind of crazy over here, if you'll take the Post-it notes, we have a quadrant here, finding the data you need. If you had problems or you really like something, put your comments here, creating charts and graphs, exploring the data, and other. Please help us provide Keith and his amazing team the feedback that they need to make this tool work for your classes and your students.
Yeah, okay. User testing in action.
Yeah.
And I see a slide, so let's jump over to
Now we
Bob
have Bob
Downs.
Hi, am I
Lighting
supposed
away.
to use a mic for the people?
The mic is.
Mike's
the
there, so-
owl
Oh,
right
the
there.
owl, yeah.
Use your teacher
My
voice.
friend.
My friend the owl.
Yes, yeah, so, hi, I'm Bob Downs, and I'm from the NASA Socioeconomic Data and Application Center. We just call it CDAC. And we have lots of data that are often from a variety of different disciplines, but they, more importantly, they serve a lot of different disciplines. And in fact, here you can see this graphic that's showing a group of 15 major fields that are using data that are in their articles. So they're citing our data. And these are just from articles that were randomly selected from journals that had cited our data during 2021 and 2022. So you can see there's a lot of different disciplines here, so it's applicable, our data are applicable to lots of different subject matters. You can, teach geography, obviously, with them, but, we even see clinical medicine here. So our data are so applicable to so many fields, so I think, if you want to give your students a foundation in using data, and do it in the classroom, this is a good data center to visit. And our focus is on human interactions in the environment, but we're also serving as an information gateway between the earth and the social sciences. And then later on, I'll be here and be giving a demonstration of one of our mapping tools, our disasters, hazards mapping tool. And so I'll be back later to do that.
All right. Thanks, Bob. Jumping over here to Nissa. Am I saying it right? Nissa?
Yeah. Hi, I'm everybody. I'm Nessa Rain. I work for GST, it's a contractor, but it's NASA. I'm working with Terra mission, like one of the old satellites, but a goodie. It's a good one. So I'm here today to pitch the Stella, which is a instructional tool designed by Paul Merrill and some other Landsat folks. But basically, it has CO2 and air quality, like PM 2.5 and 10. And yeah, so I'm gonna give a talk later about it, but if you have any questions about where it came from, etc.
Play with the toys?
Yes.
Play with the toys? Okay. I'm gonna bop over to Charlie and Andrew at the Arboretum.
Cool. I'm Charlie Zander. I just want to do a brief shout out for Eco Explorer. If anyone is not familiar with that program, or a community science project focused towards kids, we help to encourage outdoor learning by providing all kinds of different exciting topics to learn about throughout the year. We mostly focus towards kids that are not in classroom environments, but more and more we've been working with classroom teachers as well, to thinking about ways that their kids can observe birds and trees, reptiles and amphibians, mammals, and that their observation data can really make a difference for science. And where we find ourselves in this conference is thinking about how kids can both be observers, but also analyzers. And as we've grown, we've seen the kids have also grown, and their interest in science is so diverse and exciting. So what we love to do with Eco Explorer is to provide hands-on activities, ways of engaging with research that are really personal and creative, and get kids excited and activate those memories that I think are important for so many of us in finding our passions. So really focusing at an early age. But if there are projects that help kids thinking about wildlife that are accessible, you can reach online, we love to help connect our kids to those tools. Loved learning about a lot of things at this conference in ways that kids can actually analyze and interact with data, and making that a seamless and easy experience. But yeah, we work with tons of partners in North Carolina. Some of you work with us, which has been fantastic. But yeah, just excited to continue learning. And so if you have any questions about that project or what we do or how we could do things together, please come and say hello. And I'll let Andrew also talk a little bit more about the North Carolina Arboretum, which is super close to here. If you haven't been, you should check it out.
I don't have too much to say, but I will connect. One of the things I work on annually is as I said in my introduction earlier, the Mountain Science Expo, which is a part of the North Carolina Science Festival. North Carolina Science Festival.
Just louder, please.
Yeah, no worries. So that is a STEM festival, and it's one of the only dedicated STEM events the Arboretum does. We're typically focused more on environmental education and those various aspects. The Mountain Science Expo is all-inclusive, and I'm always interested in getting more of a STEM presence, more of a data-driven, more of a scientist presence as well. So this is almost more directed to the facilitators and the presenters today than the attendees. DuPont, for instance, is already working with us and was grateful for their presence this year. But if any of you have interest, or know someone in your organization who would have an interest in presenting or having some sort of activity related to the work you do there, I can give you my information if you want to come up to me at any point. We'd love to have you be present.
And just shout out to Andrew for making such a fantastic festival this spring. It was really awesome and just so energetic and fun. And so, yeah, please join us if you can.
Cool. All right, so that's good. I think Shelley.
Okay, yes, I didn't really introduce like where I work and all that earlier because I knew I'd have this chance. I work for EarthScope Consortium, which is the integration of IRIS and UNAVCO, if you've ever heard of either of those, earthquake science and geodesy science. And today I have a cool tectonic motions as measured by GPS poster of a subset of all the stations that exist in the Northern Hemisphere that our organization are managing. There's a lot more by USGS that they manage their own resources and other universities, but you can actually see how the ground is moving. And so I have a few small models to talk about, doing kinesthetic modeling with your students and how this kind of stretchiness might be similar to what you would experience in California with the transform boundary. And then this kind of cat toy for compression spring, how that is similar to the kind of compression that you see in the Pacific Northwest. So I have stickers. I have a lot of different kinds of stickers. You're welcome to come over and pick one up. And thank you to Carla who picked up the last the list of activities that was printed out for a different conference, but she picked one up, and so now we have this, so you can at least do QR code scanning, and I'll put this in our participant folder as well. So come on over to visit, and I'll be talking a little bit later as well.
Okay. I think I have everybody who is in the room who is on the list.
For some folks not on the list, because I invited Funding Friday folks to also share their materials.
And this is a great
Right
time
now?
for that.
Okay.
Oh, it's a great time for
When
that.
people can come and talk to you.
Okay,
But,
so-
give a lightning spiel.
So I did do the Friday funding last year. Last year was my first time at ESIP. As I said, I'm a retired middle school science teacher, but I'm also involved in, University of Colorado has an outreach program, and we bring sort of STEM science experiences to different areas of Colorado. I live in Louisville, Colorado. For 2 years ago, we had a horrible fire. It really devastated and in some ways continues to devastate our community. 1,000 houses were lost and another probably 3,000 were destroyed in some manner. Anyway, kids in my area are very interested in wildfires now, and even though we live in a more rural environment, and also air quality. And so after attending ESIP last year and this meeting specifically, I learned about some interesting satellite data, especially with the GOES satellite, that impacts air quality, and also ways to identify wildfires using satellite data around the country. So I created a lesson, which I will put out my poster actually in just a second, it's back there, that you can sort of look at what kids did. I had them take some real-time air quality measurements. Then we looked at different satellite data so they could see what they actually understand even what satellite data is. And then they explored different websites, and we had a game they played to understand the air quality impacts on your lungs. And then I had them do an art project, and I have some examples to show you of what they did at the end when they put all this information together. I did it through 4th through 8th graders. So I'll have it up.
Good example, Vicki.
Yep, so, excuse me, I joint founded a program with 2 middle school students about 10 years ago. At that time, it was called the Citizen Science Education Program. It's now called the Community Science Education Program because 2 years ago, the students thought that community sounded more inviting and it better explained their mission. There's 2 basic parts to the mission. One is to take what they learn in the classroom and turn it into community outreach. And the second thing is to improve their junior scientist skills by actually doing research and going to things like the Globe Student Research Symposium and that sort of thing. To put on a science summit, which is something that we did early on in the program, it requires about between $3,000 and $5,000. And so I wasn't sure where that money was coming last year, but the grant really helped with that. So in March, 23 middle school students, and I have a video if anybody's interested in seeing it, but for those of you who are interested in maybe doing Funding Friday, I have a picture of my poster so that you can go ahead and see that if I can do it, you can do it. And the students taught 23 stations, actually a little less than that, but
and we had about 350 community members come into school. It was a 4-hour ordeal, a fun ordeal. Now, I was gonna say to you that the students thought it was an ordeal because to talk for 4 hours, they were like, how do you teach? And I'm like, okay, now you'll appreciate that more. But we talked about the 5 basic ideas of the Earth System Science Initiative, but my students just called them the 5 big ideas of science because they found out, well, you can teach every discipline through earth science. So why don't we do this? Anyway, they broke up, if you want to see some of the activities that they did, but they talked about all sorts of things. We had a travel through time, which used modeling to talk about the 4.6 billion years that the Earth has been in existence, using a calendar. But anyway, but it was great, it was wonderful. The money was used to buy banners, to buy props, you know, but it was really an excellent way for them to do their community outreach and teach, make the community more scientifically literate.
Fantastic. And we have Randy Neff from the Smoky Mountain STEM Collective, who has stuff to share.
Yeah. So this was kind of a last minute thing, so apologies that I haven't been more thoughtful about what I've brought, but I just pulled out everything that I thought a teacher might need. I've got this Landsat poster is lovely because on the back of it, there is a game. Okay, so all of this stuff except for the Braille Earth is for taking away, and you can take as much or all of it as you want. So if you want a whole classroom set of those, go for it. And if there aren't enough left over, let me know and I will get them to you because they're taking up a lot of space. So I brought family level stuff and little kids stuff, and I have a newsletter that we put out. The Smoky Mountain STEM Collaborative is a project through NASA's Science Activation, as is Teresa's. So I connect people in Western North Carolina with NASA materials. And I don't know if the Globe, you didn't mention that they have Globe Educator 1-week pacing guides. So I brought trees and the carbon cycle. So anything over here that you found, and the book that you guys shared this morning, I have them in Spanish. So you're welcome to take those as well. Thanks.
All right, thank you. Anybody else in the room have something interesting on their mind? Oh, share. All right, so if you do, you'll be talking. We have a half hour now. This is the unconference portion of our conference. We're gonna get up, walk around to whoever you want to, and don't feel like, oh, I have to stay with this person because I picked them. Wander around the room, pick up your resources, talk to people, ask the questions that you wanted to ask while they were talking. And we'll warn you when you have about 5 minutes left. It's also free for all, so hop, hop, out of your seats, go. Yeah, okay. Shelley's gonna introduce herself.
Okay, so Bob Downs will be here in a few minutes to talk about CDAC. But I just want to give a quick 10-minute and give me like a, this is 5 minutes.
Okay.
Kind of thing.
So you went halfway through, you want to say?
Halfway through and then 1 minute and then yank me off the stage. So, Shake Alert, sorry, it came up as Shake Alert. EarthScope, that's where I work, is the merger of 2 organizations, IRIS, Seismology. Anyone ever hear about IRIS? Okay, we have 2 people.
Flower.
And then UNAVCO. Anyone ever hear about UNAVCO? Oh, we have 1 person, 2 people, yay. One that does seismology, earthquake science, supporting earthquake research, and then the geodesy side, we do the same. We support geodetic and other measurement kinds of science. We are funded mostly by NSF, and I had to look it up because it's wild. So we run the geodetic facility for the advancement of geoscience and the seismological facility for advancement of geoscience on behalf of the National Science Foundation with a little bit of funding from NASA and USGS. Okay, now that we know who our sponsors are, there are 2 tools that I want you guys to know about because they're really cool. So you might notice up on the screen, oh, I need to share.
I was just gonna wander over and whisper that to you.
Well, anyone online, you really didn't miss anything yet? Because the really cool stuff is right here.
Yeah.
Okay. So this is the Velocity Viewer, the GPS Velocity Viewer. GPS is a satellite system that the United States takes care of. GNSS, which is the Global Navigation Satellite System, is like all the different technologies that are out there that provide navigation. GPS is one of them. Over the past decade or so, or more, I've been working with our data scientists to make the data more understandable and usable in a classroom environment, to provide data that they could take and actually put into Excel and it will work, versus not being able to do anything with it because it's a .pos file, and who's ever heard of a .pos file? But a .txt or an Excel file, it's like, yeah, okay, we understand it. Or to create a visualization tool. So here is a subset of the GPS data that is part of the network that we manage. And yes, it's very similar to this poster over here. In this case, we're only showing 1 out of 20 vectors, but we can zoom in, which is kind of nice. You can't do this on a poster. And so, anyone want to shout out a particular city in California?
Long Beach.
Okay, let's go down to Long Beach. Help me out here. There's Long Beach.
Right below LA.
There it is, Long Beach. And
You see how
these
a
are-
non-Californian is pronouncing Long Beach.
These arrows are vectors. At the tail, that means the area that's not with the little carrot top, that's where the GPS actually is sitting. Probably these out here are on islands that are very small, or it could be on a platform. And then the length is representative of how quickly that GPS station is moving, using a reference frame where the middle of North America has been set at 0. So we've removed this background motion. And then the direction is the direction of the arrow, the vector. So you can see here, it's like moving, 20, 40, maybe millimeters per year. And you can actually do some exploration. And we're going to be updating this. So ideas are welcome. But one of the nice pieces of this is you can then put in the station labels and they will pop up eventually. We're on a slow server. And then you can go in and get more data. And one of the wishes to our updating of this is so that you can kind of, it's called interrogating the data, but you might call it filtering the data, or being able to do some analysis, like maybe, like you might do a profile for earthquakes, which I'll show you in a second. You could do that same thing with vectors. And why is that important? Well, let's say we look at a station that's here, none of the P ones are showing up. We'll look at this one. So BTIS, and it shows you a lot of data, information, the latitude, the longitude, the horizontal speed. It's moving 40 millimeters per year. Well, let's look over here. This one's only moving 8 millimeters per year. And I did this as a little kinesthetic thing with
Tim.
Tim, I had it right. Could I get a volunteer here? So let's say you're moving at 8 millimeters a year, stand next to me. North California is right there, the ocean's right here, and you're a GPS station and I'm a GPS station. And you're going to only take a tiny step, and I'll take a giant step. And each step will represent 10 years worth of data collection. So step. Nope, just one. Step. Okay, what do you notice here?
It's getting stretched.
It's getting stretched. What would happen if Abel let go of this? Say it louder.
An earthquake.
An earthquake. Yes, and that is, the land is storing all this potential energy. Thank you, Abel, you were great at this demonstration. So we have activities that are physical and, like I said, I have a piece of paper over there and I'll put it online with activities that connect to the Velocity Viewer. Do I still have 5 minutes?
Well, yeah, you have about 5 minutes, I stopped counting, yeah.
Yes,
You have 5 minutes, I was busy taking a photo.
So now we have another tool. This is from the Sage side. It's called the Interactive Earthquake Browser. So while the Velocity Vector one, we can plot earthquakes. It's a static data set, and you can't really investigate that data set. All we can say is, oh yeah, there was an earthquake here, and those symbols tell you the depth, but it doesn't tell you anything else about it. So again, this is like, we want to merge some of this together so you could look at both kind of data together. So this is showing you not only where the earthquakes have been in the 1,000 newest earthquakes, it's also showing you the depth and the size of the earthquake. And so here, these are all purple, meaning they're all shallow, and they're kind of small circles, so they're probably in that 3, 4, 5 range. But if you go to other parts of the country or world, let's go down to Chile. This is a lot of fun. And yes, there are other tools out there. Concord Consortium makes a tool that is very similar to this. It has its positives and negatives, just like this one has positives and negatives. Excuse me, you can also then do a 3D view. And I'm trying to remember, I think you just click there, and whoo! And then you can start seeing the depth. Now I didn't zoom in, so it just gave me the whole continent.
That's totally fine.
Wow, yes.
So I could get back out, but I'm on a PC, so,
So that's the depth of the earthquake.
so those were showing the colors and the physical
Size.
size. Yeah, the size is like the magnitude, the
Right.
color is the depth, and, I'm just gonna, oops, I closed that. That is not what I expected. Iris, IEV. Fortunately, there's nobody else who has the name of Iris IEV, so we'll go back in. Okay, so you want to zoom in, 3D view, and I didn't like pick a zone, but what do you notice here? These were shallow, these are a little bit deeper, these are even deeper, and these are really deep. What kind of plate boundary is
So
this?
the movement is where the more movement is where the red is, where you're showing the elastic bands, right?
No.
No, it's the opposite?
No, these are static, these are earthquakes.
Yeah.
So it's actually modeling the edge of the subducting plate that is the Pacific plate below Chile.
So that's the plate itself is
So that's
going,
the plate
itself
itself.
is doing like this.
So these are locating like where the plate is.
I never knew you did that. By the way, you got about 2 minutes or 1 minute or something.
Okay.
Or something.
So you could kind of do a similar activity looking at the vectors and then coming up with what kind of plate is this by, did I mention that I'm not a PC user? Multiple
Can you do a
times.
hotspot? Like, can you go to Hawaii and do the 3D view of the hotspot?
You probably could. and
Or
I would
Yellowstone,
say-
Yellowstone just.
Or Yellowstone, yes.
Yeah,
that's 1 minute.
Yeah, on a PC. On a PC where
No
the
pressure.
mouse is really slow. But you can see kind of that similar concept in the GPS data. And so this will show up eventually. Just give me 30 seconds. It's a 20-year-old product with, and it's still in beta.
20 years.
Yeah, because we've never had any real funding. It's me begging for funding. Anyone know what that is?
The theme teacher?
So the vectors will eventually show up here.
What are the diamonds?
The diamonds are earthquakes,
Okay.
and the size of the diamond tells you how kind of severe the earthquake was. User error. I turned off all the vectors.
Is this in real time by chance?
Well, not the data. The data has been analyzed and it's an average over the year, so millimeters per year. But here you can see these are fairly long, these are getting shorter, and these are super short. And so instead of seeing the subducting plate and the dots that's showing the upper plate, we're just seeing how this plate's being compressed inland. And the longest ones are storing the most energy to the least energy. And then if we have an earthquake, it'll be a big one because that whole area is going to relax at once. Relax and release energy. So anyway, 2 tools, thought you guys would be interested. And now I think we should move on to
We got Bob Downs.
Oh,
All
great.
right, Bob.
Well, thank you very much. So I earlier talked a little bit about CDAC, just to introduce it to you. And now today, what I'm gonna do is introduce you to one of our tools. And I'm not brave enough to do it live, like Shelley did. So I'm just going to, I have a bunch of screenshots that I can show you. So this is our website, and you'll see you have these little pull-down menus here. Under Map, you have mapping tools, and that's where you would click. And then that would give you a page of a bunch of tools, and I'm showing you some of them here, but we're going to go and select the CDAC Hazards Mapper. And then that will bring you to the landing page for the CDAC Hazards Mapper. And it tells you a bit about it, plus it gives you use cases describing various scenarios where people would use the Hazards Mapper to conduct some kind of analysis or to do a visualization. But what you do is, you see the arrow, you would click Web App, and that brings up the actual web app. But before we go there, I wanted to just show you some of the layers that are in the tool here. And so you have earthquakes, which is relative to what Shelley was showing us. And we also have aerosol optical depth. We have dams and power plants. And then we've got fire layers. The base is using the gridded population of the world data But on top of that is a service called the Population Estimation Service, and I'll demonstrate how that works too. The interesting thing about the Population Estimation Service is by itself, it can be used in other people's tools. So we've got others who are using our Population Estimation Service in their services, so it's kind of a neat thing to see them out there being used. And this is for actual practice with people who are trying to accomplish things on a daily basis, such as you know, if there's a imminent danger out there, a hazard or something, and you're trying to figure out what population is at risk, you can do that. So anyway, this is the CDAC Hazards Mapper. And at the bottom here, you see the legend. So it's telling you what these little features are. And on the top left, you see plus and minus zoom. You probably see those on lots of applications that you're using. And on the right, you have another pull-down menu where you can actually see those layers, and we'll look at that. So if you click that, you see those. And then on your left, just below the zoom, you see a couple of icons there. One is for a polygon, and the other one is for a circle, and we'll talk about those a little bit later. So right now, obviously, what we're seeing is kind of a global view here, but if you zoom in, you can see less. And if you turn on different layers, you can see these represented on over the globe in the location where they're represented. So you see here, we've got the fires turned on, obviously, and the earthquakes. And we can have chosen any of these others here, you can see them. But I wanted to draw your attention to the flood outlook, which is in the middle of your screen on the right. I've got a little hollow arrow there for that. So if you were to go to look at the flood outlook, and then you zoomed in, you could see a flood area. So what we're looking at here is it's an area just to the west of Chicago. So you see the large population on the right is Chicago. That's kind of in purple, all that purple, blue. You see the polygons are this shaded area and right in the middle of your screen, and that's where the flood, likely flood event is. So you can also, if you look in the bottom right, you can see there's a flooding possible, and that might give you a lot more choices of areas, but I just wanted to show you flooding likely so that we could just focus in on one area here. And so we see this little area just outside of Chicago where there's a flood. And then we see we have some options where we say number one is to draw a polygon. So if we clicked on that, then our mouse or whatever tool we're using to do the clicking with would enable us to draw a polygon. And then if we clicked on the points here around the flood, you see there's so many points around this flood. If we click on those, we can get a bunch of dots. You'll see them here. And so what I did here is I clicked the first point and then the second point, third, etc., going all the way around here. So I basically have outlined this whole flood area so that we can use that as the area that we're going to focus on. And so what happens is when you click on the last point, it says here, well, I should actually say the first point, but when you go all the way around and you click again on your first point, that closes the shape. And once your shape closes, then it's going to do this calculation thing which will take some time, like it could be a minute or two, depending on the size of the area, because it's gonna calculate the population in that area, and that's why I don't do a live demo. Then what it will produce for you results. And so what it's telling us here is in this area that I selected, you can see the name of the area here is Rockford, and it's very close to Loves Park and Fireport, etc. Now that we've zoomed in, we can see all the names of these little towns, or suburbs, whatever you want to call them. And we also see our results. So in this area, it's 5 million, over 5 million, almost 5.5 million people. And it also gives us the estimated land area. So that is for, you can do that for all kinds of hazards, but it kind of works out easily for the flood because it does the polygon for it. So I wanted to quickly show you the circle, how you would use the circle to do that too. So now we're transporting ourselves, if you will, over to the Philippines. And here we're seeing an earthquake, and we look on our legend and it's blue. So it's a magnitude of 5.1 to 6. So if we zoom in on that area, we can again, on the left, click on the tool, and this time we're clicking on the circle, and then we go over and we click on the center of our earthquake, and then we drag out to decide the distance of our radius that we're going to choose to measure. Okay, so I clicked on the center of the earthquake, and then I pulled it out with the mouse, and then I let go of it. And then it does a calculation, which might take a minute or two. And then here, we're seeing here, yeah, this is approximately a 25-kilometer radius that I selected around that area. And you see there are 67,000, almost 68,000 people living in that 550-kilometer area. So that's how you would use the hazards mapper. And if you wanted to do a hands-on exercise, you could do that with your class. Basically, you could open up the hazards mapper. You could select PowerPoints, for example, and then have your class looking at, and you will actually see the image of the power plant. And you could discuss information about the power plant that's displayed there with your class. And then you could select dams, do the same thing. And then you could select an earthquake, for example, and do the exact thing that we just did here. Anyway, with that, I want to thank you for your attention, and hope you enjoy, and hope your students enjoy using the CDAC Hazards Mapper.
Thank you, Bob. Oh, we have a question. Fair enough, Bob. All right, so I'm on the CDAC, and right now it's showing flooding possible for USA only, but your slide had more options. Is it because there's only one, like, if it doesn't have, there were a couple options you had on your, you go right. It's gonna be right there. So you have flooding possible USA, flooding likely, flooding possible, there's two possibles?
Yeah, I don't know why that's down there twice.
Okay.
But with the flooding layer, if we look up at here at the list of layers here is flooding in an urn here. Let's see. Yeah, I think I only listed the global layers here.
Okay.
And flooding is a USA only. And so we wanted to get it because it is valuable if you're looking in the USA, but you won't get it for the rest of the globe. And I also should mention, you, Shelley just reminded me, we brought in a bunch of these fiber cloths, microfiber cloths, that they have printed on it different global maps. I think we have one in there of the GERDI, I don't remember what that stands for. And we have cute names.
Gridded relative deprivation index.
Yes, yeah. So we have lots of global products, and I think we have some maps in there too for the gridded population of the world, which we just call GPW. And that's on version 4, revision 11 right now, but I should tell you, because we're quite excited about it, we're working on version 5. And it takes years to develop these GPW versions because each collection of GPW contains lots of data sets. And so they're like 9 in version of 4 of the collection, 9 data sets. And it took, I think, probably 5 or 6 years for a whole team to develop that, because they're getting data from different countries.
So I just wanna, so going back to would I go
Actually,
zoom in?
Can I just, I'm sorry, could we talk to Bob about the questions of this now?
All I had was, it's not showing both floodings, it's only showing one right now.
Flooding is only showing in one area.
It's only showing flooding likely, it's not showing both of them.
Okay, yeah, well, if there's, let me just go to that one. Okay, if there's no flooding possible, which means.
Then it's not gonna show up.
Yeah,
Okay,
there has to
that's
be
what I thought.
flooding there right now, but flooding likely is, they think there could be flooding. That's why, I tend to go with flooding likely for an example, because I will get something there. And the other one, flooding possible, well, it's kind of hypothetical, people are estimating that. But flooding likely is more likely that you'll have flooding there. And yeah, I actually had a better example I wanted to show you from the week before, which is flooding in St. Louis. I don't know if you all remembered that a couple weeks ago. And I wanted to do that one, but they were doing something with our system at the time. And I called our service people, help desk, and I said, what's going on here, because I'm going to be giving a live demo of this. And they said, oh, well, we'll let you know when it's back up. They never let me know, I didn't yell at them. But when I got back in to do it again, the flooding was over. So I couldn't show you the St. Louis flooding, because that was all of St. Louis. It was bad. And I don't know what the story was on the street, how it was there, but yeah, I know in my own town it was flooded for Hurricane Irene, and it was like 300 homes and businesses. It was pretty nasty. So it could be really an event.
Yeah, thanks for showing that, and hopefully you can use it in either your classroom or in an informal setting.
And so I am Doug Brown, research scientist with North Carolina Institute for Climate Studies, based in Asheville, North Carolina. We're part of NC State University, also affiliated with NOAA's National Centers for Environmental Information. And I think Andrew, right? Like you work for Arboretum, so we were at the
Mountain Science Expo.
Mountain Science Expo, right? So I'm gonna just try to share some resources. We create a list of resources for educators, and I'm going to showcase one specific things here while we try to figure out where the slides is and and the link of the resources. So this, if you go to go.ncsu.
Can you share that screen?
Okay, sure. Screen share. If you go to go.ncsu.edu/ environmental literacy. Dash literacy. So that will takes you to a Google Doc we recently created.
You're good to go,
Okay.
Douglas. I'll get Lisa next.
Right, ta-da! We get to the Google Doc, where if you look at it, we like put all the resources into one document, including different categories for weather, climate, oceans, earth science, as well as trying to separate them into different grade levels, where those informations might be relevant to different grade levels when you're trying to use that for the information in your classroom or in doing your outreach and educational events. So this, for example, if you go to the elementary school category, when under the weather, there are different examples from Discover Labs and activities and other things put out by UCAR Center for Science Education. So this is not a resource, this is not only resources from NOAA, but it's resources from different places, including GLOBE, which is a program that NASA and Department of States like USAID have funded together, trying to working on those citizen science projects for mosquitoes, for land cover, land use, and cloud, and etc. So the slides is less important, but just trying to give you the background of what we do with our institute, and then give you an overview of the resources there already. So I can go back to tell you a little bit about what we do. And also this is my emails in case you want to get in touch if you are from the local regions and want to have us to visit your schools. We do that as well, and your different groups. So that is my information there's an email address for both my NOAA one and the NC State one, and we are parts of both NC State and NOAA. And that is where we sit, like in Asheville, and our motto is the inspire, advance, and engage, where outreach and education is really part of our mission. We talk with schools and garden clubs in the local regions. We do adult education through the Arboretum, North Carolina Arboretum, and the UNC Asheville Lifelong Learning Institute as well. And we are with NOAA through the Corporate Institute for Satellite Earth System Studies. We are the hub in the North Carolina. There's another hub in Maryland. So if you're in the Maryland region, we can definitely connect you with our colleagues there. And also we work closely with the State Crime Office, also located in North Carolina State University. So this is a QR code. If you are not able to type in the link, this is a QR code to directly link you to the resource that we created. That on the right side, you already see that. And if you can't remember the link, we created that for environmental literacy, and that has been used. And we are also trying to put that on our website as well. So one specific resource I want to show you is the NOAA Data in Classroom. They have different course trends. Data in the classroom, yes. So that shows you how you can really use NOAA data directly in your classroom, right? So they have created 5 modules. El Nino, which is one of the climate variability that you have heard a lot in the news over the last year. And you have sea level, and you have coral bleaching, water quality, and ocean acidification. And if you look at the El Nino, that takes you into different online modules as well as the guide for teacher. And there's some worksheets for students, as well as the answer keys that students can use directly, and different things may related to the science standards from the NGSS, and also how can you integrate those modules into your curriculums and teaching and other things. So another specific thing that you can use is called Science on the Sphere, which is something we always like to show the kids and other things, that you don't, when you first create it, it's like gigantic, like digital globe, right, that you can put in your museums and students can interact with it, but it has a lot of data sets in it, so students can look at it. What we also have is an iPad version of it. So you can just download it on an iPad for the students and then they can interact, choose different data sets on that. Okay, and I think that's the only thing I want to share. And so that's the example of the data in the classroom. So I'm happy to answer any questions, or if you have any comments or things you want to see more in the resources, please let us know, because it's Google Doc, we can update those information really easily.
Thank you.
Right.
So I have. Can you get that? You gotta remote.
Okay. Hi, everyone. I'm Nessa Rain. I'm representing Stella AQ. It is originally was designed to be a handheld spectrometer made from Landsat to teach kids about red, green, and blue bands and how that can tell you things about plant health and things like that. I wanted, for my own personal experience, I wanted CO2 and also PM, and that's hard to get in a combination product. And so I talked to some intelligent, amazing people at NASA, and they were like, hey, we can do that. So it's modular, so it costs $200, it's open source, instructions will be provided to y'all. Right now we're going through like a funding thing, so the website is currently down for maintenance, but it will be back up and it will have everything, and I'll give y'all everything in advance anyway. So basically it measures humidity, temperature, and pressure, CO2 concentration, and air quality, and PM, particulate matter. So in case you were wondering I'll skip that part. Here's how satellites measure it. It's the same kind of principle as a spectrometer, so it's really interesting that you can use this for many different ways in the classroom. And then connecting it back to something like, this is the Dark Target, they combine a bunch of different satellite data sets, so I work on Terra. That's my jam. But it combines all the air quality data and then filters it, so you can make products from the satellite data, and then a lot of these that are coming out recently are focused on air quality as well. In addition to the new missions that we have, Tempo, PACE, coming up, I think. So in case you wanna know what PM is, particulate matter, it's really just like heavy stuff, and then the 2.5 versus the 10 is how big it is, so small, large, right? And then CO2 is important for outdoor and indoor,
Wait,
right?
could you go back
Oh.
to the previous slide?
Yeah.
Slide. The one that looks like a horn, that's a human hair?
Yeah,
Yeah.
this is a hair.
So the width of our hair is about 50 microns, so that means 2.5 is really, really tiny.
Really.
It gets into the lungs and then gets into our bloodstream.
Yes, and it's the
Right.
most dangerous form of like air quality problems. And they found like more and more that even just a little bit is bad. So it's important to know what's in your air. CO2 is another important indicator, especially indoor. Outdoor, it's used for calibration. So I don't know if you've seen the Stella that I passed around, but if you breathe on it, the CO2 will spike and it'll come back down. Kids love that. It's like instant science, instant, you see it happen. And then my kids were like, what happens if we put it in the car? What happens if we open the window? What happens if we, and they just come up with these ideas. And it's,
What about cooking bacon?
oh my God. No, the worst, like, chefs really need to, butter is like the worst thing. PM-wise, if you cook butter, it spikes like crazy and it won't like, so I have all these ideas of like, you bring a burner into the classroom, you let it burn some butter and then you just look at it. Watch how it changes over time. So, outdoor air quality, you can obviously visibly tell the clear skies versus smoky skies. And this was, I don't know if y'all went outside yesterday, it smelled a little smoky in the afternoon. So it was kind of high like yesterday afternoon, and then the rain came through and kind of like cleaned the air out a little bit. So you can, because there's tons of resources, I'm sure you'll know of all the air quality resources online, but a lot of cool graphs and charts you can do with this as a tool. So indoor air quality, we should care about it more. We spend 90% of our time indoors. And yet it's some of the most disgusting air inside the places, especially in schools.
Yeah.
And so this stems out of me trying to get data from maintenance people for my kids' schools, because they were saying a certain number of ventilation, right? There's science behind this, and they couldn't provide me data, so I got mad. And I snuck in a CO2 monitor in my kid's bag, and it showed that it's not ventilated, like it's not. So it's important. You're giving kids the tools to hold adults accountable, right, for their learning environment. I just think that this is such a great, Stella, wherever it is. Stella. So anyways, you can look through this, but this right here is disgusting. If kids want disgusting facts, you should teach them about air quality, especially indoor. You breathe like 1 out of 20, and this is not uncommon. Like 2,400 is not, like in here it's 1255 right now. So we're already in here, 1 in 50 breaths someone else has breathed out.
I wanna stop breathing.
Don't do that. Breathing's
Open a
important.
window.
Yeah, you wanna watch that video if you get a chance. So I was gonna have you do a little activity, but we don't have a lot of time, but just thinking how you could apply this to your own classrooms, in your own environment, your educational settings. Like, I'm sure y'all have amazing ideas, but this is just a tool to help facilitate some of this, some of these connections between air quality and satellite data too. I'll link it back. So, yeah, this is what it looks like, graph. So my friend, coworker, he built a bunch of these, and so I modeled his house, and he had an open door situation and then a closed door situation. And it's, so obviously you open the window, closed window, open window, CO2, dramatically different because ventilation. But if you have a wildfire outside, you need to know if you need to open the window or filter through HEPAs, right? And so NOAA, I think, has a Corsi Rosenthal box activity. You can build it, and this would go amazing with it. Also, people have already used this for middle school in Arizona. They do Corsi Rosenthal boxes, and they'll build them and put them in the classroom. They'll teach kids about air quality, indoor, outdoor, how it relates. And then these kids actually went and took data, not with the Stella, but with its similar project, and there's a Corsi Rosenthal box. It's just basically a HEPA filter, right? We should have them everywhere. And also UV light, but that's different. This is just a placeholder because the website will be back up momentarily. But there is, if you want to Google, there are articles out there that do talk about it. And like I said, I'll provide all the things for you. I actually also wanted to share one more thing, but it's not on here. Basically, this originally came from a social justice course that I developed for North Carolina School for Math and Science. And it was about COVID and social justice. And so, as you might know, marginalized people are way more at risk for COVID. And so it is a matter of, similar to like redlining, when you see air quality differences between redlined areas and not. It's a social justice issue for sure. And so I think that's like the main message of Stella Q, is like making it affordable for like anyone to be able to use science, do science. But if you want that course information, I have all that too, including like lesson plans, like standards. It's all done. So happy to take any questions.
Yeah, somebody wanted to do this with a class. Would they get a Stella for each student, or would they pair up? What would be ideal?
It's about 200 per unit. I don't think you would need one for every student. I think it would be probably want groups of like 4 or 5, just because that way you can compare data between the Stellas. You can do a bunch of stuff. Calibration validation, sorry. I'm not at NASA right now. I can't just drop cowbell. Calibration, validation, everything's an acronym in NASA.
So where do you
But
get the tools to build this stuff?
So it's all listed and I have it material-wise. It was all, and you can buy that Adafruit, so it's online, you just buy the parts and you connect it, there's no soldering required. So this is good for middle schoolers. And the coding is Circuit Python, so it's not too intense code-wise, so, yeah.
And you were mentioning earlier that you could maybe just buy one or two of the components.
It's modular.
And then add as you have time and money. And, there's this thing called Funding Friday that I was just thinking.
Yeah.
You could possibly even pair with another teacher here to, compare data from one place to another, just
I would love that.
Yeah.
Pushing this up, yes.
Is there a way that data, and you may have said this, but is there a way that data can be linked into a computer? Like I'm
So-
thinking of using a CubeSat,
Okay.
putting some of these sensors in, using like a high altitude balloon or
Okay.
kites or something like that.
You're thinking along the lines of NASA's doing it right now.
Right,
They're,
okay.
they're working on that part, but also, this one has a mini SD card, so it'll come out as an Excel sheet.
Nice.
And it has all the labels and everything. You can reset how frequently you want to take the data. So right now, I think it's like every 5 seconds, it's a lot. But the next version of it, they're gonna put a Bluetooth / Wi-Fi, something that allows it to like API in to like a
Right.
repository or something like that.
And this replaces like the Calitu, the old Calitu that you could never get.
Not quite.
Okay.
That's different. That's more points directly up. It's a different process than this is more smaller, localized, in situ measurements.
And this is also an education outreach
Yes.
tool.
Yes.
As opposed to a Calitu that is more used as a scientific tool. I think they're working on getting the publications and the validation and all of that done. This is pretty new, so use this with that in mind.
And that's, you don't really wanna keep track of CO2, that's not the point of it. The point is to measure a room and see, and to just show kids the interactions between how air quality changes inside.
Yeah, the changes would be.
But, yeah.
And in indoor, I mean, for rooms that are ventilated, I mean, my
think
classroom
there's
had mold
Yep.
like crazy. Are there any kind of biosensors
They're
that
working
you
on
can
that
use?
too. Yeah.
Excuse me?
They're working on that too.
Working on that.
They're
Okay.
putting, I think they're putting methane on there, I think there's some organic components that are gonna go on to the next one, so.
Well, there's also a spectrometer,
Yes, that's
the
right.
regular Stella that you could measure all of that.
Yeah. That's, yeah.
I just have a question. You said you have all of this. Where do we find this?
I'm about to give it to her, she'll give it to you.
So it'll be
Yeah.
a website.
It'll be-
I put a few
yeah.
resources up already and then,
I'm gonna build like a makeshift one while they figure out who wants to have it.
And how about the
Written.
slides? Have you given us the slides?
Yeah, she hasn't.
Perfect. They'll be in your resource folder.
Yeah.
Yes.
Shelley's probably already done it.
Yes.
Yes.
Well, thanks for letting me come share this with y'all, and if you have questions or, want additional resources on all this is what I'm here for.
And do you still have time after the workshop if
Uh,
anyone's interested? Or
might
do
have
that
to
might be,
I might have to, well, I might have to run, just.
Okay, no
I live
problem.
here local.
Yeah.
But I just appreciate you having, yeah, I'm a wealth of information. And local connections too, like Greenworks is amazing. There's a lot we could do here, so.
We could also do a follow-up, webinar.
Okay.
That's what I was
The
thinking.
education
Yeah.
committee.
Okay,
All right.
thank you all so much. So,
Feels like maybe that.
I guess I'm up.
but now, we have
We lost people.
Charlie, you gotta go present.
going further with Teresa Schwerin and Charlie Zimmerman.
Yeah. So this is part 2 of this morning's talk about GLOBE. And I'm going to talk about some resources and partnerships, and hopefully there'll be more fuel for your ideas for Funding Friday. And you guys, I am so jealous that you're going to New New Belgium tonight. It is fun. They got food trucks. It's in the Cool River Arts District section. I didn't plan well. I'm not going, but I'll be here through the end of the day if you have any questions about this. So I'm going to go through some things, and then Charlie talk a little bit about a partnership we've been growing between my group and Globe and North Carolina Arboretum. So, reminder about Globe, that it's an international program. I focused on the 4 tools in the app that you don't need any special equipment or very little equipment if you want to do additional things, but there are almost 40 Globe protocols. It covered things like aerosols, think Stella data, AQ, water quality, green up, green down. There are almost 40 different things that you can measure. But you do need to get some training. And if you go to this webpage, you'll find out places you can go to get training if people are offering face-to-face training. They also have e-training online. If you go that route, it's not a seamless process, so reach out to me and I'll help you with how you navigate that part of it. So just wanted folks to know that's an option. The GLOBE program has an international virtual science symposium. And as educators, whether you're in a formal classroom or you're out of school, learners that you work with can submit their projects to this symposium. And so it's online. Students who submit their research, it gets reviewed by STEM professionals. They get feedback on it. They can get badges. One of the badges, I'm a data scientist. And they are entered into a drawing, those that rate in the top tier, to go to the annual GLOBE meeting. So lots of opportunities with that. There's also in the United States a student regional symposium in different areas of the country. I think Vicki knows really well about that. There's also another opportunity. So another place to take research with data that students are doing. And this year's theme, sneak peek at it, is 30 years of GLOBE, understanding the past, present, and future. And so they want students, learners to use GLOBE data, the GLOBE database. It has over 250 million observations as part of their project. So it doesn't have to be them collecting data. It can be them going into the database and using data. And it can be with additional data. So many of these tools you learned about, those make a nice complement to doing student research using GLOBE data. We have a toolkit for informal educators. We have a lot of classroom teachers that use these as well. I mentioned earlier the items that were designed in this kit. We field tested them in out of school settings. We did design them so that they could be adapted, and we want people to adapt them, take them and use them, put them together however works for you. So the resources in the toolkit, they include hands-on activities, games, resources, videos, all things that help build the content knowledge and the skills to do the observations. So I'd encourage you, go look in the toolkit on your things that you might put together for your Funding Friday project. We work with a group called SciStarter. People know about SciStarter. It's a portal where you can find citizen science projects, and they have a partnership with the Girl Scouts. So if you work with the Girl Scouts, they use GLOBE clouds, trees, and mosquitoes as part of, think like the Citizen Scientist Project. The Girl Scout Tree Promise uses a tree project, and the Girl Scout Climate Challenge. We also have in our toolkit a GLOBE Observer Girl Scout Guide, and inside there's a link for the SciStarter Girl Scout page. So if you're working with Girl Scouts, another resource you can use. Also SciStarter, as well as GLOBE, we work with libraries. And this is a citizen science kit that SciStarter did. The newest one is mapping mosquito habitats. We partnered with them on that. And so it's a kit, they tested it with libraries using resources from our toolkit and new things that they added. And their kits that either a library can check out, can use in their programs, We also work with Los Angeles Public Library, and I've got an example in the back corner of a backpack that they developed with our materials. That's a DIY neighborhood science that you can check out, go home, do citizen science. And teachers have an extended checkout period. More partner resources, the Smithsonian Science Education Resource Center, Mosquito Community Research Guide, the National Institute for Environmental Health, part of NIH, the Climate Change and Human Health Lesson Plans, Neighborhood Science Toolkit from LA Public Library. The MyNASA data, Angie mentioned, resources, lots of connections to GLOBE, and they have pacing guides on different GLOBE topics, including mosquito habitat mapper, trees, urban heat island, that are a sequence of 5 one-hour activities. If you want to do like 5 in a week, or if you want to space them out, but they're really nice sequence of activities using the data, GLOBE data. Oh, I had that in there twice. I liked it so much, I put it in there twice. If you're working with 4-H, we've got a 4-H activity guide. There's an NSTA article by Madeleine Colon-Robles, who is at NASA Langley, who is the science lead for NASA GLOBE Clouds, who's part of our project. That's really good with 2 teachers who talked about, here's how we implemented GLOBE Clouds in our classroom. When COVID hit, like a lot of people, we had to pivot and put together the activities for at-home science and families. I encourage you to take a look at this page. Each page includes a simplified activity, a video demo, questions that kids might have, an explanation of why it's important to NASA, suggestions of adaptations, and then links to larger collections of activities. And field tested it with 14 families. We have an article in NSTA Connected Science Learning about it, and it's another collection of resources. So take a look at these things. They're resources you can use and adapt. We want you to use them and adapt. Newest feature in GLOBE Observer. We tested this out for the eclipse. It's called a geofence. And what that means is if someone's in an area that geographically is defined by the geofence, they open the app, they'll get a pop-up message saying, hey, you're here, would you go take an observation? So we did it for the eclipse. Before that, we had a NASA Moon Tree Challenge. And if you want to learn about that, I won't take the time now to talk about it, but come see me. But when you were in the area where one of the Apollo 14 moon trees was planted, popped up and said, hey, you're near this moon tree at the North Carolina Botanical Gardens. Why don't you go over there and measure the tree height? So this is something, if you're interested in a project for your region that uses one of the GLOBE Observer tools, think about that. It could be a community science project. Okay, Charlie and I in North Carolina Arboretum, we've been working on different things related to Eco Explorers, and we're looking at things, possibilities for the fall. We've done some things related to clouds and trees. So Charlie, do you want to talk a little bit about what your plans are for the fall?
Yeah, thanks so much. And if you weren't here in the room before, I'm Charlie again. I'm here from the North Carolina Arboretum. And yeah, it's been such a pleasure working together with Teresa. We're a program that tries to inspire and enable kids to be scientists and to contribute in actual ways to research and get to meet and talk to scientists. And Teresa has been phenomenal in helping our kids connect with folks that are doing amazing things with community science collected data, and then also contribute to those projects as well. And our program at Eco Explore, we have a badge system where we focus on different topics at different times of year. And so we've aligned several of our past badges with GLOBE Observer tools. So the first, I think, was trees, which is on my back, and that was a badge that we launched during botany field season, so focusing in on trees. And it was a perfect fit because kids were outside already taking pictures and making observations of where trees are and identifying them as species and submitting those to iNaturalist. But now they have the opportunity to actually measure the height of the tree and submit those observations to researchers that are then coordinating that with satellite data, which is well above what we were doing before that. So, and the great thing is it gave kids the opportunity to then connect to this totally separate way of thinking about the world and very quantitatively. And then we had an amazing virtual lesson with Brian, I believe. with the- Yes, well,
The cloud costume.
you're getting ahead now, you're thinking of the climate badge, so we
Oh.
did two wonderful
That's right,
collaborations
that's right.
with Globe Observer. So the second one was the climate, and that's when we were working with Marilyn, and again, doing another wonderful virtual lesson, talking about the amazing science of clouds. But then I could mention that the actual kids, in order to earn their badges, one of the activities they could complete is directly participating in the Globe Observer project, and we give them some tools and some tutorial to help them feel acquainted to the project and help it fit in with the rest of the way that we generally display lesson plans to our learners. So yeah, just a really wonderful connection to the themes that we were talking about, again, for some of our older kids, thinking about environmental topics and conservation and ways that they can have a greater impact on the world. But then, giving them the tools to make observations as well as analyze data. And so looking ahead, one of the things that we are excited and have discussed is connecting to our fall field season that's just around the corner, is our water badge and our ichthyology field season. So that's the study of fish. Folks aren't familiar with that science term. But water as a concept aligned with fish is so many applications to earth science, and one of them is connected potentially to mosquitoes. So thinking about how kids can actually help support real-time observations of where mosquito habitat is present, and make observations and actually identify mosquitoes would be really exciting and fun, and connect really nicely with the water badge theme. So this kind of way of kids deepening their knowledge with a different kind of project that has their brain thinking in a different way is really exciting to us. Part of the thing I was hoping for too at this conference is to hear folks' ideas if they have had great experience doing mosquito habitat mapper related projects or other kinds of ways, maybe in a classroom setting, because we predominantly help kids explore in like either families or sibling groups. Homeschool groups are really popular. Sometimes they're also working in a classroom setting with like a teacher, but sometimes they are at the driver's seat, and so they have to do a lot of the lesson kind of planning on their own, or we're helping guide them in the process, but we're trying to provide tools that are easy to use and straightforward. So yeah, any troubleshooting could be really helpful in that realm, and also just other ideas of connecting to water. We have a host of other things on the horizon too. We just finished our soil badge. In a couple of years, we'll be coming back around to climate and air. So these are all topics that I think relate to a lot of the data programs that are kind of present at this conference. So yeah, just very excited about the potential for that. And also for our EcoExplorer kids being enabled to be data scientists too. So not just like making observations and kind of putting it out there, but actually looking at what has been observed by other students or professionals and doing analysis and coming and potentially presenting at the International Science Symposium. That's a really cool potential thing. We're actually in the process of applying for grants too to develop more inquiry-based badges, learning curricula that are even more focused towards classroom learning environment, which we've not done as primarily until now. That's been more of our sibling project, Project Explorer, if you're familiar with that program. But yeah, those are just a couple of the things that we've talked about and would be excited about doing in the future.
Thank you.
Yeah.
And two very quick points. I know my time is running short. Vicki made a really good point earlier about if you make the focus, you gotta find lava, They're gonna be disappointed because you may not find lava, but keep in mind, the number zero is data. And it's important, when does mosquito season end? So the fall is perfect for this water badge because it's kind of bookmarking the end of mosquito season. So, important point. Yes.
Well, I'll
And then
let you
the
finish.
second point,
Yes.
when you take a cloud observation, within a couple of days, you get an email from NASA with the corresponding satellite image. And I worked with a library in Kentucky, and this